Software developers who want to build apps for Android mobile devices need Android Studio, an integrated development environment, or IDE, that's available for free from Google. Android Studio is based on IntelliJ IDEA Community Edition, a leading Java IDE from JetBrains. Like Android Studio, IntelliJ IDEA is available for Windows, Mac OS, and Linux, and the Community Edition is also free. But you don't need IntelliJ IDEA to create Android apps. Android Studio has everything you need. Android Studio was first announced at the Google I/O conference in May of 2013 and was released as a 1.0 product in December of 2014. It's been through many iterations since then. In fact, it's updated frequently, between 2 and 4 times a year. It inherits great code editing and debugging functionality from IntelliJ IDEA and adds lots of tools that are unique to Android development: layout editors, resource editors and managers, tools for managing the Android SDK and virtual devices, and lots more. This version of the course covers Android Studio Arctic Fox. That's a name, not a number. And that's because with this version of Android Studio, there's a new versioning system. Each version gets a nickname and a number. This version, which might have been numbered 4.3 in the old system, is now referred to with a year and a month that are derived from the base product IntelliJ IDEA. So Android Studio Arctic Fox is also Android Studio version 2020.3.1. There are some new features since the last version of this course. Some windows have moved around, changed names or appearance, and other features have been improved. This course is designed for software developers who want to learn how to build Android apps using Android Studio, the free integrated development environment from Google. This course focuses on building Android apps with Kotlin, the newer programming language from JetBrains, the same company that created IntelliJ IDEA on which Android Studio is based. If you're brand new to Android development, what do you need to know first? Well, to build the apps themselves, you'll need to have some mastery of the Kotlin programming language. And so you can watch the Kotlin Essential Training course, or you can dive right into this course because you won't be doing a lot of programming in it. The focus is on the tool, not on building complete apps. But in order to build those apps, go to that beginning course. And if you have any questions about the code you see, most likely you'll find answers there as well. There are many other courses in the library that will teach you more about using Kotlin specifically in the context of Android, but I'll talk about those at the end of the course. Android Studio is based on another IDE called IntelliJ IDEA Community Edition. This is a free IDE from JetBrains. And just like Android Studio, it supports code editing, refactoring, debugging, and so on. In fact, almost all the coding tools are exactly the same between the two products. What's different in Android Studio are the tools that are specifically for Android development. To learn more about the details of working with IntelliJ IDEA, you can watch this Essential Training course. So again, the more you know about IntelliJ IDEA and the more you know about Kotlin, the more effective you'll be as an Android app developer, but this course is designed to help you get started from scratch, just learning how to use the development tool. This course was originally recorded with Android Studio Arctic Fox, the first version of Android Studio that used a name rather than a version number. But since then, a new major release has come out named Android Studio Bumblebee. It appeared in January of 2022, and it includes many new features and a lot of improvements. I'll cover some of these features in some depth in the updated videos in this course. The new Device Manager tool window is one of the most visible changes. It replaces the old AVD Manager interface. The old version appeared as a pop-up window, while the new version is a fully integrated tool window. But more importantly, in addition to creating and managing virtual devices, it can now also be used to connect physical devices for debugging over Wi-Fi with a greatly streamlined process. This new version of Android Studio also includes improved support for running tests using Gradle. And for those developers who have Mac OS-based computers with M1, M1 Pro, or M1 Max processors, this version of Studio now runs natively on that platform. There are new tools for inspecting apps at runtime, including looking at the status of background processes such as jobs, alarms, and wake clocks. There are also new and improved tools for inspecting application layouts and improved support for working with activities and fragments that are built with Jetpack Compose. For design work, there are new preview and picker tools for working with graphics. I'll be covering a few of these new and improved features in this update, but for complete information about this new release, check out this blog post on the Google Android Developers blog. You can run Android Studio on Windows, Mac OS, Linux, or even on Chrome OS. The system requirements for Android Studio are listed on the Studio page on the developer website. On all platforms, you need a 64-bit development computer. On Windows, you'll need x86 64-bit CPU architecture, and that can be either an Intel or an AMD chip, and on Mac, you'll need either an Intel computer or one of the newer M1 computers. On Linux, any 64-bit Linux distribution should work as long as it supports one of the desktop environments that's listed on this page. Chrome OS has its own unique requirements. If you do want to run Android Studio on Chrome OS, I recommend a Chromebook that has at least an i5 processor. And even on that processor, it can be a little bit slow. i7 is a lot better. On Windows and Mac, again, i7 is great. And while 8 gigabytes of RAM is listed here as the minimum, 16 gigabytes will make you a lot happier. Everything will just work a lot faster. One other critical capability that all computers need to run well on Android Studio is hypervisor support. Android Studio uses virtualization to support the Android emulator. This is the tool that lets you run Android instances in a virtual device and not have to have a whole stack of physical Android phones and tablets around to test your application. If you aren't sure whether a particular computer supports virtualization, check its technical specs or check with the vendor. And finally, you do need a minimum screen resolution of 1280 by 800, but higher resolution is better, and if your development environment supports more than one monitor, you can move windows around and make a very comfortable development environment. So check to make sure you have a development computer that's going to run Android Studio well. It needs the memory, and it needs the up-to-date CPUs, and then you'll be able to build and test your Android apps quite easily on whichever operating system you choose. You can download Android Studio for free from this page on the developer website. The process of installing Android Studio differs depending on which operating system you have on your development computer. There are installer packages available for Windows, Mac OS, Linux, and Chrome OS. When you visit this page, you'll be offered a download for your operating system, and you can get to that by clicking the Download Android Studio button. But you can also find all the different versions of the installer by clicking this button for Download Options, and this is where you'll find all the different packages. On Mac OS, you can now choose between versions optimized for Intel or Apple Silicon processors. When you click the Download button, you'll see a license agreement. When you accept a license agreement, these download buttons will be activated, and you can choose the package for either Intel or Apple. Regardless of which you choose, you'll get a DMG file. When you open the DMG file to install the software, just drag the application package into your Mac's Applications folder. I'll go back to my download options and show that there are two packages for Windows. An exe file, that's a traditional installer application, and a zip file that lets you just extract the files onto your disk. The executable installer application is recommended, and that's the only choice you'll see if you just click that download button at the top of the page. But if you choose the zip file, you can then navigate to the folder where you installed Studio and then to its bin subfolder and open the Studio 64 application. On Linux-based computers, you'll get a tarball file. Before starting Android Studio, you may need to install some tools that the software depends on. You can find instructions for both Linux and all the other operating systems on this page at developer.android.com/studio/install. These are the instructions for Windows and for Mac, and then for Linux you'll see this link for required libraries. And when you click that, you'll get instructions for various distributions of Linux. On Chrome OS, you'll first need to install the Linux subsystem. You can find instructions for that at this page on the support website. The Chrome installer package is in a DEB file. Once you have Linux installed, you can install Studio by downloading, right-clicking, and selecting the install option. And finally, going back to the main installation page, from here you can also select Preview. And this will show you various testing versions of Android Studio. At any given time, there are usually 3 versions available. The stable version, available from the main page, a beta or release candidate version, which will be on the left side of the screen, and a canary version, which is an early release, a version that Google is working on but may not be entirely stable yet. Choose the version that works best for you. If you're building production applications, I highly recommend using the stable version. But if you want to see what's coming in future releases of Android Studio, those testing versions are also available. The first time you open Android Studio after installation, you'll see the Android Studio Setup Wizard. This screen looks pretty much the same on any operating system, and it'll walk you through the steps of configuring and downloading the Android SDK. Click Next on the initial screen, and then you could choose to just use standard settings, or if you want to customize, select this option and click Next. Android Studio is packaged with a copy of the Java Development Kit, or JDK. As of the time of this recording, it was Java 11. If you want to use that version, and I recommend doing that, just accept that setting and click Next. Now you can select a UI theme. I prefer the light theme, so I'll select it and click Next again. And now I choose what I want to install. This screen will look different depending on what you already have installed on your computer. If you don't already have the Android SDK, you'll need to select this option. And then I do recommend installing the most recent version of Android. At the time of this recording, that was API 31 or Android 12 Preview. Also, you can create an Android virtual device, but I don't recommend doing that during this process. I'll show you how to do that later. Next, you'll want to select where you're putting the Android SDK. On Mac OS, the recommended location is under your library directory under your own home directory, and then a directory structure called Android/SDK. On Windows, the recommended path may be deeply buried. I recommend changing it on Windows so that it's in a similar location under your home directory where it's easy to find. Wherever you put it, you'll be able to find it later easily in the SDK Manager interface. Now, I'm seeing this message because I already have the Android SDK installed, but if you don't, this is where the SDK will be downloaded for you. Click the Next button, review whatever you see on the screen, and then click Finish. And again, if this is your very first time installing Android Studio, it'll take some time while everything is downloaded and installed on your computer. If, like me, you already have the Android SDK installed, you'll see this Nothing to Do message, and then you can click Finish. And when you get to this welcome screen, you're ready to start building Android apps. Before you create any Android Studio projects, it's a good idea to update the Android SDK and make sure you have all the components you need to support your Android app. From this version of the welcome screen, go to More Actions and choose SDK Manager. Or you can go to the Customize link and go to All Settings and go to the SDK Manager under System Settings, which is under Appearance and Behavior. Either way, you'll see a listing of 3 tabs at the top: SDK Platforms, SDK Tools, and SDK Update Sites. The Android SDK location shows you where you installed the SDK. Notice that there are many versions of the Android SDK available. Each one is attached to a particular version of Android and has that Android version number, the letter or sweet snack code associated with that version of Android, and an API level. It's important to know which API level you're targeting when you build your Android apps. Whichever API level you're targeting, you'll need to have that version of the SDK installed. Right now, as of the time of this recording, we were in mid-range preview for Android 12, so that's what I have installed. But if you're building production apps, I suggest using the latest stable version. You could just check this checkbox, but there's a lot more information that's available, and to get it, click on Show Package Details down in the lower right-hand corner of the screen. And you'll see all these different components for each version of the SDK. In order to develop with Android 11 or R, I'll choose Android SDK Platform 30, again that's the API level, and I'll choose the sources for that version. That makes it a little bit easier to debug. Everything else you see here are system images for use with the Android emulator, and you don't need to install those now. You'll be able to install them later when you create virtual devices. Next, go to SDK Tools and check for any indications that there are updates available. Minimally, you'll need the Android SDK build tools, and the version numbers should match the API level that you're building against. You'll want the latest version of the Android emulator and the SDK platform tools. All of these options are only useful if you're going to use certain features of Google Play services. If you're working on an Intel-based computer, you can choose to download and install HAXM, and that's the software that speeds up the emulator on Intel-based computers. Now, you don't need to do anything in the SDK update sites. That's all set for you. Once you've set all your options, click on Apply, and after reviewing your changes, click OK, and then you might see a license presented. For each license that's presented, you'll need to accept it, and then you can click Next, and your download and installation begins. Depending on how many components you need to download and install and the speed of your internet connection, this could go very quickly, or it could take 10 or 15 minutes. So be patient and wait for the process of downloading to complete. If you chose to install the HAXM software, you'll see this screen, and I recommend accepting whatever the proposed memory usage is, and click Next, and then click Finish. Now, I got an error message only because I had already installed the HAXM software, but I'll show you how to install the software separately in a later video, so don't worry about that. Click Finish, click OK, and you'll come back to the welcome screen and be ready to create your first Android project. Android Studio and the various components that make up the Android SDK are updated frequently. Each time you start up the software, it'll check online to see if there are any available updates. The welcome screen looks different than this when you have a project already created, and if so, you might see a little event icon in the lower right corner, and from there you can effectively upgrade the software. But if you don't see that, you can always update from the Settings or Preferences screen. From this version of the welcome screen, I'll go to the Customize category, and then I'll select All Settings. From there, I'll go to Appearance and Behavior, System Settings, Updates. To watch for updates, you need to select a channel. If you're just using Android Studio for ongoing development, I recommend using the Stable channel. Then you'll only get updates to software that's been fully tested. You can also choose the Beta channel, that's what I'm using, and then you'll get the latest betas and release candidates. Or if you're feeling adventurous, you can choose the Canary or Dev channel, and you'll get very early releases that aren't fully tested. From this screen, you can click Check Now to see if there's an available update, and I've set this up so I'm using a late beta, and now a release candidate is available. From here, I can click Update and Restart, and it'll take a few moments for patch files to be downloaded. Then, Android Studio will automatically restart, patch its installation, and then you'll be using the latest version of the application. The amount of time this takes will depend on which operating system you're working on. The upgrade process is relatively fast on Mac OS and a little bit slower on Windows, but seldom takes more than a couple of minutes. And once you come back to the welcome screen, you'll be up to the latest release in your channel. Now, again, if you're only interested in creating apps, I recommend sticking with the Stable channel. You should only see occasional updates of the core software, perhaps every 4 or 5 months. But if you want to learn about changes that are coming to future releases, or you want to help test the software, choose the Canary or Beta channels. You'll see more frequent releases, and you'll be able to submit reports for any bugs that you find. To create a new Android Studio project, start at the welcome screen. Click the New Project button, and then on this first screen, you'll be asked to choose a template for your app's primary activity. The simplest is called the empty activity. It doesn't give you any functionality other than just displaying a little bit of text. If you want to step up a little bit in complexity, try the basic activity. It has 2 fragments that are managed by the navigation component. And then there are many other templates here for more advanced functionality. I'm going to choose the empty activity template and click Next. Now, I should mention that these are just the templates for phones and tablets. If you're creating an application for Wear, for Android TV, or for Android Auto, there are also templates for those. I've selected Empty Activity and I'll click Next. Now, I want to indicate the name of my application, and I'll create it as My First App. Next is the package name. The package name is also known as the app identifier, and it has to be a universal unique value. That's why it starts with reverse domain notation. You can start the package name with your company or organization's domain, reversed, so com goes first, or org or edu, and then the name of the domain and something to identify the app. This value should have no spaces and must be all lowercase. Next is the location of your application. By default, applications are created in an Android Studio projects directory under your home directory, but you can place them anywhere on disk you like. It is recommended you place them in directories that don't have spaces in the names. Next is the application's primary language, Java or Kotlin. Android is a Kotlin-first platform now, so I'm going to be doing all of my development in Kotlin. Next, select your minimum SDK. This will indicate what the oldest version of Android is that you're going to support. If you're developing a production application, the current recommendation is to set your minimum SDK to API 21 or Android 5. Now, by choosing a more recent version of Android like this, you will lose out on a little bit of the market. To find out how many devices approximately you won't be able to run on, click this link, and you'll see the cumulative distribution for each version of Android. If you set your minimum SDK at 5.0 or Lollipop, you'll be able to support about 94% of existing devices in the market. But if you go to an older version, you'll just have a lot more work to do to support those older versions and test on them. So there's a compromise to be made, and right now Android 5 is a good call. Now, if your goal is to try out applications that work on the most recent version of Android, an early preview, you should set your minimum SDK to that version. And for example, here I would set it to API 31. But our goal is to create production applications, so I'll go back to the original recommendation of API 21 or Android 5.0 Lollipop. You can leave this option unselected. Legacy Android support libraries are older versions of components that are no longer being updated. By leaving that unselected, you'll only use what are known as the Android X libraries, and we'll talk about those and their dependencies later. I'll click Finish, and that creates the new project. If this is the first time you've created your project, it might take a few minutes while various components are downloaded to your development computer. You can watch the status of that down at the bottom of the screen. For example, right now on my screen it says Gradle, and then it's downloading something, and then I see a message saying Configure Projects, and when all those messages stop happening, then your project has been built and is ready to test. You might also see this message, Android Studio performance could be improved. And I do recommend following the recommended actions if you see this message. Click on the Actions menu and choose Use Recommended and Restart, and that will immediately restart Android Studio, and you'll now be making better use of the available random access memory on your development computer. When the application settles again, you should see one window on the right that has 2 tabs, a main activity class, in my case it's written in Kotlin, and a main activity.xml file, and this is the XML layout that determines the appearance of the screen. And over on the left you'll see the project window showing the file and folder structure of your project. You might also see a window on the right that has a whole bunch of documentation about the latest features in the newest version of Android Studio. You can click on this minus icon in that window to close it. So now, if you've built your application and you don't see any errors, you're ready to start adding functionality to customize your Android app. All Android Studio projects have a common file and folder structure. The basic structure hasn't changed through many versions of Android Studio, but there is one significant change you'll find in Android Studio Bumblebee, in the creation of what are known as Gradle build scripts. For this demonstration, I'm using an application that I've just created using the basic application template. This application has 3 code files, 1 activity and 2 fragments, and it has a good collection of resources including layout files, drawables, and so on. So let's start in the manifests directory. The manifest is where you define the components of your application. For each activity, you'll find an activity element, and then as you add other activities or services, those components are also defined here. The Java directory exists regardless of whether you're using Java or Kotlin, and it's where you put your code files. By default, a base package is created that matches the application ID. In this example, it's called com.example.myApplication. The project window shows this as a flattened location, but you can uncompact it by selecting the gear icon and then deselecting Compact Middle Packages, and then you'll see the actual folder structure that underlies this area of the code. If you want to reflatten it, select the gear icon again and reselect Compact Middle Packages. So all of your Java and Kotlin files go here. You'll also see other matching packages labeled Android Test and Test. And this is where you place your testing files with unit tests for testing application logic and instrumented tests for testing how the application behaves on devices. You'll see a directory here called Java, and it's notated as generated, and this directory contains files that you should never change. They're automatically generated and maintained by Android Studio. The RES directory is for your resources. There are subdirectories here for drawable, for graphics, layout for layout files, menu for menu files, mipmap for other graphics, navigation if you're using the Jetpack navigation component, and values. And this directory contains XML files that define string, color, dimension, and other kinds of resources. You'll also find themes files, and this is where you define your application themes. And once again, there's a generated folder here where various files are generated during the build process. Anything that's in the generated folders, you don't touch. Next, we'll get to the Gradle scripts area. I'll close up the app module here and go down here, and you'll find that there are 2 build.gradle files. The first is the project-level Gradle file, and this is where there have been some changes. In the past, this file contained a lot more information. There's still this plugin section that defines the highest-level components of your application. But in the past, there were also definitions of what were known as code repositories. In Android Studio Bumblebee, these settings have moved to a file called settings.gradle. These are lists of available repositories. I'll come back here in a moment after we look at the app modules Gradle build file. When you build your application, your main application is stored in this app module, and a build.gradle file is created for that. This file starts with a list of plugins that you're using in the app module, and then there's an Android section that defines your application. It includes things like the application ID, which matches the base package for your code files, the minimum and target SDK, which defines the SDK that you're building with and the minimum version that you want to support, a version code and a version name. The version code is an integer, and it has to be unique for each release, and the version name is an arbitrary string. And then under build types, you can indicate in the release section whether you're going to minify your application. That is, whether you're going to compact it and strip out unused resources and code. There's a compile options section, a Kotlin options section, And then, really importantly, a dependencies section. This is where you define libraries that your application depends on. A dependency is a simple string. It includes identification of the library and the version number. And if you see these versions highlighted like this, that means there's a newer version available. You can click into this and then use an intention action and change it to the most recent version. Whenever you make changes to these files, you'll be prompted to resync your application, and that will cause Android Studio to go get the libraries from code repositories. So now let's go back to settings.gradle. This is where your code repositories are defined. Your primary two repositories are identified with these two method calls, Google and Maven Central. The code libraries that are referenced here are stored in these online repositories. So when you sync your Gradle project, Android Studio walks this list of repositories and finds the libraries you've asked for. It downloads them and it integrates them into your application. Now, we've been looking at this file structure using something called the Android scope, but it doesn't represent the actual file and folder structure in your computer storage. To see that, pull down this list of available scopes and choose Project. And now the root will be the location of your project on your disk, and then you'll see all these folders and files where they're actually stored. And you'll see a couple of hidden folders now called .gradle and .idea. And these folders contain important configuration files. Most of the time, you won't need to deal with them at all. They'll be created and maintained as needed by Android Studio. But again, this represents what's actually in your storage on your hard disk. And at any time, you can go to any of these directories, right-click, and then go to Open In and choose whatever application is appropriate for your operating system. I'm on a Mac, so I see Finder, and I can get to that location on my disk. The basic file and folder structure of an Android Studio project hasn't changed since Android Studio was created, but there have been minor changes in where information is placed. And again, in Android Studio Bumblebee, the biggest change has happened in the project-level Gradle file and the settings file. Google provides many sample applications that can help you learn how to use various components in your Android apps. To import these projects, go to the Welcome screen, and if you're looking at the Welcome screen after you've created at least one project, you'll see an Options icon up at the top, labeled More Actions. From there, choose Import an Android Code Sample. In the Import Sample screen, you can search for whatever feature you're wanting to learn. For example, let's say I wanted to learn about Work Manager. This is a component in the Jetpack library collection that makes it easy to run background tasks. I'll choose that sample. I'll click Next. I'll indicate where I want to put the project, and then I can click Finish. You can also click on this link to see where the project is stored on the GitHub platform. If you have GitHub installed and you're ready to use it within Android Studio, you can also install the application that way. I'll come back to this screen and click Finish, and that results in downloading and opening the project. Most of these projects will have been built with an older version of Android Studio. And when you install them, you may see a link pop up asking you if you want to do something called upgrading the Android Gradle plugin. Each version of Android Studio has an associated version of the Gradle plugin, and Gradle is the software that helps you build and compile your application. It's very important to have a matching version of the Android Gradle plugin for your version of Android Studio. If you see this message, click on the link, click Begin Upgrade, and after a moment you'll see a list of required steps. Click on Run Selected Steps, and then you'll see a bunch of stuff being downloaded from the web. If you haven't run through this process before with this version of Android Studio, it'll take a little bit longer. Once the process is complete, the project will have been upgraded for this version of Android Studio. If the project has an MD file, that's a markdown file, you might see this message asking you if you want to install plugins to support markdown editing. I'm not going to cover that here because it goes beyond just being able to read these files. But if you're familiar with Markdown and you want to install a Markdown extension, you can start the process easily from here. I'm going to click on Ignore Extension. Once you've done all this, you're ready to start running or at least looking at the code. I'll go to my app module, and from there to the Java directory, to the project's base package, and then I can open up any of these files. These files are written all in Kotlin. I can examine the code in this sample project, borrow whatever I want, and implement the same features in my own Android app. Android Studio's appearance and behavior can be customized to your liking in many ways. Most of these changes are set through the dialog that's named Settings on Windows and Linux and Preferences on macOS. On macOS, go to the menu and select Android Studio and Preferences, while on Windows and Linux, you can go to the File menu and choose Settings. Either way, the structure of the dialog is the same. You'll see a menu on the left with categories: Appearance and Behavior, Key Map, Editor, and so on. Under Appearance and Behavior, you can change the theme from IntelliJ Light to Darkula or to High Contrast. I'll switch to Darkula and click Apply, and everything looks different. And then I'll switch back to IntelliJ Light. If you like, you can choose a custom font for the entire IDE, or you can use the default, whatever the IDE selects for your operating system and device. You'll see sections on this screen for accessibility, for various UI options, anti-aliasing tool windows, and presentation mode, which is a special visual mode that shows your code in a very large font. Also under Appearance and Behavior, you'll see that you can configure your menu in various ways. Under System Settings, you'll find the Updates option that I showed previously, the Android SDK Manager, Memory Settings, and other configurations. The Key Map section lets you set up your own keyboard shortcuts. You can choose one of the default key maps, or you can create your own copies of these default settings and then customize them in various ways. Under Editor, you'll see a font setting, and this is where you can control the font for your installation. You can select your own mono font, and you can set your own size and line spacing. You can also set something called a fallback font, and this is a font that kicks in if there are any symbols that aren't supported by whatever font you do select as your primary. There are settings under Editor for color scheme and code style, and under code style, there are settings for all the different supported languages, including Java and Kotlin. This is where you can control things like whether you're using tabs or spaces, how much you're tabbing in if you're using spaces, how the IDE will adjust your code whenever you do automatic reformatting, and also critical tools for managing how code is generated. Again, these settings are language-specific, and that's also true in the color scheme section where you have special rules for Java. Continuing down, you'll see that there's a section for plugins, and this is where you can install various plugins for the IDE. Now, the one plugin that you don't manage from here is the Kotlin plugin. That's handled down here under Languages and Frameworks, under Kotlin. And this is where you can see which version of the Kotlin plugin is installed in your copy of Android Studio. I'll talk about version control a little bit later, but this is where you would set up your GitHub account. And there's also sections under here for tools, build execution and deployment, and so on. As you can see, there are dozens of possible configurations that you can use to control how your copy of Android Studio looks and behaves. Once you've completed setting up your settings, you can save them by going to the menu and choosing File, Manage IDE Settings, Export Settings. When you export your settings, you'll get a zip file that contains all of the settings that you selected, and then later on, if you need to restore your favorite settings, you can re-import them from here as well. Android Studio is very configurable, so take a further look into the Preferences or Setting dialog and see what other settings you might want to change to make Android Studio look and behave the way you want. In order to test your Android apps, you'll need an Android device. And many developers use virtual devices that are run within the Android emulator. If you're working on an Intel-based computer that runs either Windows or Mac, you can significantly speed up the performance of the virtual devices by installing a piece of software called the Hardware Accelerated Execution Manager, or HAXM, from Intel. This software is stored on GitHub at this web page at intel/HAXM, and you can also get the latest releases by going to the Releases folder under the repository. You'll see that there are zip files for both Windows and for Mac. Now, you can also get HAXM through the Android Studio SDK Manager. In the SDK Manager, you'll find the HAXM installer here, and the version that's included with Android Studio may not always match the latest version on the GitHub repository. If there's a difference, I recommend using the most recent version from Intel. The installation process for HAXM is pretty straightforward. Regardless of whether you're working on Windows or Mac OS, when you run the installer, you'll be asked to assign a certain amount of memory that will be used by your virtual devices. The amount of RAM that you assign will depend on how much your computer has. If you have a computer with 16 gigabytes, I recommend assigning 2 or 4 gigabytes to your virtual devices. The more memory you dedicate to your virtual devices, the more devices you'll be able to run simultaneously. If you're running either Windows or Mac, I do recommend installing the software first before you create and run your virtual devices, and then you'll get the best performance possible. To test your Android apps, you'll need an Android device. You can use either physical or virtual devices, and Android Studio will help you set them up and connect them for debugging. Android Studio Bumblebee has a completely rebuilt Device Manager tool window. It replaces the old AVD Manager and is now fully integrated into Android Studio's user interface. But more importantly, it also now supports connecting physical devices. Let's start with virtual devices. This new window appears differently depending on where you open it from. On the welcome screen, you can go to the 3-dot icon and choose Virtual Device Manager. And if you open the window from here, you're only supporting virtual devices. I'll close that and return to the welcome screen, and this time I'll open up an application, and then I'll go to the menu and choose View, Tool Windows, and then I'll choose Device Manager. It's called Device Manager here because in this format, it supports both virtual and physical devices. I'll click on the Virtual tab, and then I'll click Create Device. This screen lets you choose your device definition. There are pre-built definitions available for all the different Google phones, including Pixels, older Nexus devices, and other form factors such as Wear OS for watches, and there's a category for tablets. There are also sections for emulators for TV and automotive. I'll go back to phone. On this screen, you'll see that there's a column labeled Play Store, and some of these device definitions have this icon. That means that these device definitions can be used to log into the Google Play Store and download apps onto a virtual device. I'll choose Pixel 4. On this screen, you're asked to choose a system image. Each system image is for a particular API level or version of Android. At the time of this recording, the most stable version of Android was Android 12, but also there's API 32, which was Android 12L. And the next version of Android, Android 13, codenamed Tiramisu, was also available for testing. You have to have downloaded the system image. Now, I'm working on an Intel-based Mac, and so the recommended tab shows me system images that are labeled with an ABI of x86 and x86-64. And this will be true if you're working on a Windows-based computer too. Also, specifically for those computers, you'll see a tab labeled x86 images, and you'll see not just the recommended images, but everything going back to very early versions of Android. Now, if you're working on a Mac that has an Apple Silicon processor, you'll see something different. On those computers, your recommended list will have a series of system images with an ABI that says ARM64-V8A. And then, if you go to the ARM Images tab, you'll see a lot of the same images, but perhaps some older versions of Android too. With Apple Silicon computers, you don't have as broad a choice right now of the system images, so it's not as easy to test on very old versions of Android. Notice again that the ABI says V8A. There are other system images that say ARM with V7A. Those don't work on Apple Silicon computers. Regardless of which computer you're working on, choose an appropriate API level, make sure you've downloaded that system image, and then click Next. On this screen, you'll have choices around the startup orientation of the device, whether you're going to display a device frame or just the screen of the image, and then if you click on the Advanced Settings button, you'll see a number of other choices available here, including the amount of space that you want to dedicate to a virtual SD card. When you click Finish, your new virtual device will be created, and you can start it by clicking on this Launch button. In Android Studio Bumblebee, by default, your emulator is displayed in a tool window that's embedded in the user interface. If you want to change that, you can go to Settings or Preferences, to the Tools category, to the Emulator window, and then you can turn this option off, and then your device will open in its own separate window. I'll come back here and check the status of my device, and I'll see that it's still starting up. While that's happening in the background, I'll show you that you have buttons here to show the Device File Explorer. That shows you what's in the device's storage, a pencil icon, and a menu that lets you duplicate, wipe the data, reboot the device, or show where the device is stored in your storage. I'll close the Device Manager window, and that expands the size of my virtual device, and now I can deploy my application on the device and test my app. In Android Studio Bumblebee, when you open the new Device Manager window with a project open, you can now use it to connect your physical devices over either USB or Wi-Fi for debugging. Click on the Physical tab. You may see a device that doesn't make any sense here, labeled as API Level 1. That can be ignored. If you want to try to delete it, you can click on the trash can item and remove it, but you may see it appear again. Don't worry about that. On your physical device, you need to turn on Developer Options. Now, I'm working on an actual physical device that's being projected to my screen. I need to find an option named Build Number. The location of this option differs depending on your device and vendor. On Pixel devices, it appears under About Phone. I'll scroll down to the bottom and locate Build Number, and I'll tap that 7 times until I see the message, "You are now a developer." I'll go back a step, and now I'll go to System, and I'll see a new item labeled Developer Options. I'll tap into that, and then I'll scroll down to a Debugging section. And if I'm going to connect my physical device using a USB cable, I'll turn on the option USB Debugging and confirm. Then I'll see this dialog open asking if I want to allow USB debugging on this device. I'll select the option to always allow this from this computer and then tap Allow. Now I'll come back to Android Studio and I'll show that the Pixel 3a, that's my physical device, is appearing in the window, and it's also appearing up here where I want to select the item for debugging. This item could appear on the left side, or if you go to View, Appearance, and turn off Toolbar, it'll appear over here on the right. Now let's say you don't have a USB cable available, and instead you want to connect over Wi-Fi. So I'm going to unplug my USB cable, and you see a change in the status of the device there. And then I'm actually going to delete the device from the list by clicking the trash can icon. Then I'll click Pair using Wi-Fi and Pair using QR code. I'll leave that QR code up on the screen on my computer, and I'll go back to my device. I'll turn off USB debugging, and then I'll turn on wireless debugging. I'll see a prompt asking if I want to allow wireless debugging on my network. I'll always allow it, and I'll tap Allow. Then I'll tap the wireless debugging label, and I'll come into this screen, and I'll see pair device with QR code or pairing code. I'll choose QR code, and then I'm going to go back to Android Studio, and I'll look at the QR code on my device. I'll wait a few moments while the connection takes place, and this could take a little while for all the handshakes to be negotiated. If it's successful, you'll see a message indicating that the device is connected, and then you'll be able to run your application over Wi-Fi instead of a USB cable. This process works with Android 11 and higher only. If you have an older device, you'll need to use a USB cable, or you can go find instructions on the developer website for connecting over Wi-Fi using commands that you run from the terminal. Either way, with the USB cable or over Wi-Fi, you can now use your physical device to test your Android apps. After creating virtual devices or attaching a physical device, you're ready to launch your apps. From within the IDE, look at this menu. You'll see that there's a list of available modules, and your app module should be displayed. Then you'll see a list of your available devices. Under Running Devices, you'll see either virtual devices that you've started up or physical devices that you've attached. You'll also see other available virtual devices listed under Available Devices. When you run the app, if you select one of these, it'll start up automatically. Now, for this test, I've set up two virtual devices, one emulating a phone and the other a tablet, and I'm running them at the same time. On this list, I see the Nexus 9 is the tablet and the Pixel 4 is the phone. I'm going to select the Pixel 4 and then run the app. At the bottom of the screen, I'll see a message that the Gradle build process is running. And then after that, at some point, I'll see a message that the app is being installed. Once the app is built, it's installed on the device. Now I'll come back to the IDE, and I'm going to choose the Nexus 9 this time and run the app. Once again, I see the build message down at the bottom, and then the install message. And then the app launches on the tablet. Now I'm going to go back a step on both devices, and then I'll go back to the IDE, and this time I'll run the app on both devices simultaneously. I'll choose Select Multiple Devices, and I'll choose all the devices I want to use. I'll choose these two, the Nexus 9 and the Pixel 4. Those are the ones that are already running. And click OK. And then I'll click the Run button again. I'll see the build message down at the bottom. And then I'll see a series of install messages. And then the app is run on both devices. You can have as many physical devices attached to your computer as you need, and you can have as many virtual devices running as you have memory for. This makes it easy to run your app simultaneously on as many devices as you need to test, including phones, tablets, and Chromebooks. Android Studio has complete integration with Git and GitHub for managing your source code. The first step in working with GitHub is to make sure that you have a GitHub account and that you've connected Android Studio to it. If you don't already have a GitHub account, you can create one for free. And then you'll be able to generate everything you need to authenticate that account through Android Studio. Now, I'm starting from the point where I've already logged into GitHub in my browser. Over in Android Studio, I'll go to the Settings or Preferences dialog, and then under Version Control, I'll choose GitHub. I'll click the plus icon, and I see options for logging in via GitHub and logging in with token. Now, if you have GitHub Enterprise, that's another story, and you should check with your administrator to find out how to log into those accounts. But for a personal account, I recommend logging in with a token. You'll see this dialog, and from here you can click the Generate button. That will take you to your GitHub account to a page that lets you create something called a personal access token. All the permissions you need to work with Git from within Android Studio will already be selected. And there will be an automatic title or note for this token of Android Studio GitHub Integration Plugin. This token will expire in 30 days. If you want to make it longer, you can do that. I'll come down here and click on Generate Token. And if that node has already been used, then you'll need to create a new one. So I'll create a token with a note that includes the month and year. Once again, I'll generate the token. And I see this string is created. Now I'll copy that to the clipboard by clicking on this icon. I don't see any visual response, but it will have been copied. Then I'll switch back to Android Studio and paste the token in and add the account. And after just a moment, I see my account information, including my picture, is displayed in the screen. I'll click OK, and now I'm ready to use Git and GitHub from within Android Studio. Android Studio makes it easy to share your projects as GitHub repositories. GitHub is the dominant platform for sharing open source software. Now, when you execute Git commands, you're actually using Git software that's installed on your computer outside of Android Studio. So, you'll want to make sure that you have Git installed and that you know which version you have. To do that, go to Terminal or Command Window and type git --version. I have version 2.15 installed. On Macs, you may instead see a prompt to install Xcode developer tools. If so, you can follow that prompt, or if you want to install directly from the GitHub website, you can go to git-scm.com. For Mac users, there's a whole variety of ways to get Git, including Homebrew, Xcode, and a binary installer that's created by one particular person. On Windows, you'll see that there's actually an executable available from here, and there are also links down here to get tarballs for Linux, the Windows installer, and a variety of GUIs for Mac. So if you have Git installed, then you're ready to share a project as a GitHub repository. I'll return back to Android Studio, and I've already set up my GitHub account in Android Studio. So now I'll go to the menu and choose VCS, Share Project on GitHub. This dialog will have a suggested repository name, but GitHub repositories can't have spaces in their names, so I'm going to delete those and go with camel case for the title. You can optionally set this as a private repository. If you don't check this option, the repository will be public and searchable for all. The remote repository, that's the one on GitHub itself, is called Origin by default, but you can name it anything you want. And if you like, you can put in a description, but you can also add that later. I'm going to make this a private repository and share it. After a moment, I see this dialog that asks me for an initial commit, and it shows all the files that are going to be added to the first branch of the repository. The commit message defaults to initial commit. I'll click Add to add all those files. Then I'll see a message at the bottom of the screen saying that the project is being pushed, and then a notification. And then when I click the link in the notification, I'm taken to a browser window, and I see my new repository. Notice that it's marked as private right here. If I want to make it public later on, I can go to Settings, and then scroll down toward the bottom to a section that's called Danger Zone, and it says the repository is currently private. I'll change the visibility, and I'll say that I want to make this public, and I need to type this value, and I always cheat and just copy and paste it, and then click the button, and now the repository is public and visible to all. If I like, I can change the repository name here, and then I'll come back to the main screen for the repository, and I'll see that there's a button to add a README. I'll add a README, and I'll say, this is my first Android app. I'll preview that, and this is in Markdown code, and it's taking a moment to load the preview, but that's okay. I trust what I typed, so I'll just say I want to commit the new file, and now the README is a part of the repository. So that's how easy it is to take a project that's built in Android Studio and share it as a public repository on GitHub. As you make changes to your application, you'll want to reconcile those with your GitHub repository. That process is called committing your changes and then pushing them to the remote branch. Before you make changes, you want to make sure that your local and remote repositories are in sync with each other, and the easiest way to do that is to go to the menu and choose Git, Pull. Say that you want to pull everything from the origin branch, that's remote, to your local branch, which could be master or main. Click Pull, and then any remote changes will be pulled down to your local repo. In this case, that change involved pulling down the README file that I created on the website. Now I'm going to make a change to my application. I'll go to the Android scope in the project window, and I'll open the build.gradle file. This is the file that's associated with the app module, not the project. This file contains all sorts of configurations for your Android application, and down at the bottom there's a list of what are known as dependencies. A dependency is a string that identifies a software library somewhere, and it includes the version. If your dependencies are out of date, that is, if there are updates available, you'll see a visual indicator. And if you move the cursor over that line, you'll see what's available. I see that there's a point release that I can install. To change to that new version, I'll click into that string and then use what Android Studio calls an intention action. Hold down the Alt key and press Return on Mac, or press Alt and Enter on Windows. I'll see a menu appear with available changes, and the top one should be Change to, and then the new version. I'll accept that, and then I need to do two things. First, I can click the Sync Now button at the top, and that will download any new versions that I've now referenced in my code. But then, I can go to the Commit window, and this is where you'll see changes you've made that haven't been committed to your repositories. I see two. First is the build.gradle file that I just edited, but Android Studio has also generated a new file called vcs.xml. To upload these to my repository, I'll select all of the files. Then I'll add a commit message. This part is required. And I'll say configuration changes. Then I can either just commit locally, or I can commit and push. Either way, Android Studio will analyze the changed code. And if it sees any issues, it'll warn me about them. I can click Review. And in this case, it's just telling me that I have a plus character here, meaning any version, and it's giving me a recommendation to be specific. So once again, I'll use an intention action and say replace with specific version, and that doesn't work out too well, so I'll undo it. And instead, I'll use an intention action and say suppress this warning, and that adds a comment labeled no inspection. Now I can come back to my commit window, and once again, I'll commit and push. This time I see a push commits dialog appear, and I'll click the push button, and everything is uploaded to the remote repository. So that's how you can commit your changes to your local repository and push them to the remote repo on GitHub. Git allows you to manage multiple branches within a repository. There's a lot to learn about this area of Git, but the basics are this. Whenever you're going to create a new feature or prepare a new release of your software, it's a good idea to create a new branch for that work, test the code there, and then once you're satisfied it's ready for production, you can merge those changes back into your main or master branch. To create a new branch, you can go through a couple of different interfaces. You could go to the menu and choose Git, Branches, and you'll see this dialog pop up. You'll see your remote branches and your local branches listed here. Or you can go down to the bottom of the screen and click this icon, and you'll see basically the same menu. You can click and expand this so you can see a lot of branches if you have them. And importantly, you can create a new branch. Now, I'm going to refactor my code a little bit to use a feature called view binding. So I'll create a branch named view binding. It should be all lowercase with no spaces, and I'll create the branch. Now, any changes I make will be a part of that branch and not my original one. I'll go to my build.gradle file, and I'm going to look right in here inside the Android block. I'm going to add something called build features. I'll add a pair of braces, and I'll use view binding and set it to true, and I'll click Sync Now. And that will result in generating files that are called binding classes that reflect the contents of XML layout files. Now I'll come back to main activity, and then inside the class, but outside the onCreate function, I'll create a private variable with late in it, and I'll name it binding, and I'll set it as an instance of something called activity main binding. Now this class was generated automatically based on this XML layout file. The library took activity_main, removed the underscore, and uppercased these characters and added binding at the end. Next, I'll initialize that class with binding equals, and I'll call activity main binding inflate, and I'll pass in layout inflator. And that goes and reads the XML layout file and creates an instance of this class that has properties for each of the view objects in the XML. Then, instead of saying set content view and passing in the XML file, I'll pass in binding.root. Now, functionally, this will do the same thing it did before, but now I'm using the most recent recommended approach for managing view bindings in Android apps. Now I want to check in those changes. I'll go to my commit window, and again, you could use the keyboard shortcuts for this, and I'll see that there have been changes to build.gradle and main activity. I'll select build.gradle and press Command-D on Mac or Control-D on Windows, and that will show me a diff, a comparison between the two files. It'll show me that in this file, I've added the build features block, and then I'll do the same thing for main activity, and it'll show me that I added an import for my binding class, a declaration of the binding object, and then the initialization. I'll check in these changes with a commit message of refactored to use view binding. And I'll commit and push. So now I have two branches. I have my new feature branch, and I have my original branch. I can switch back to the original branch by opening up the branches list, choosing the local version of the branch and checking it out, and I'll see the older code, and then I can go back to the newer code. Once I'm satisfied that those changes are good, I can go to my original branch and check it out, and then I can go back to the branch list and choose my feature branch and choose Merge into Current. And that will take all the changes from the feature branch and put them into the master or main branch. And then if I'm done with the feature branch, I can get rid of it. I'll go to the local branch first, I'll click on it and choose Delete, and then I'll see this notification with a link to delete the tracked branch. That's the branch on the remote repo. I'll click that and confirm, and now that feature branch is gone from the remote repo as well. So those are some tips for how to manage your branches as you're making changes. Again, it's recommended that you create a new branch for new features or new releases, test all your changes there, and then merge them back to your original branch once those changes have been published. Android Studio has tools that let you easily check out or clone a repository. That means you're downloading the repository from the GitHub website and creating a local version of the repo on your development computer. The first step in doing this is to visit the repository on the GitHub website. On each public repository, or on private repositories that you own, you'll see this code button. Click it to open the menu, and then you'll see this URL. Click this button to copy the URL to the clipboard. Next, go to the Android Studio welcome screen and click the Get from VCS button. Paste the URL into place. If this is a private repository, you'll need to have logged into Android Studio with your GitHub account already. But if it's public, you can just download it. Notice that the default location is under Android Studio Projects under your home directory. You can change that if you want. Click the Clone button, and after a quick moment, you might see this dialog asking you if you trust the Gradle project. If so, click the Trust Project button, and you may see some error messages appear along the way. Don't worry too much about that. There's a lot of work that goes into building the project once it's downloaded from the GitHub website, and you may see these error and warning messages along the way. Most of the time, if it's a well-constructed repository, Everything will be fine at the end of the process, and you'll have a working project. If the project was created with an older version of Android Studio, you may also be prompted to upgrade the project so that its Gradle plugin matches your installation of Android Studio. Now, this process can take quite a while depending on what version of Android Studio the project was built with, so be patient, go for a walk, and when you come back, the project should have been built. This dialog is asking me whether I want to upgrade to the latest version of Android Studio. I'll click Begin Upgrade, and then I'll click Upgrade. Here I'll click Upgrade to the latest version of Gradle, and once again I'll do the upgrade, and now I just need to be patient and let the process complete. If you see dialogues indicating that there are non-project files, accept the default option and click OK. When the build process is complete, you may see some messages that need to be dealt with. For example, you may see a message that you need to be using a newer version of Java or anything else. You may also see an indication that your build tools are out of sync. If that's the case, you'll see this option to remove the build tools version and resync the project. Follow the prompts, and once again the project will be rebuilt. Once you've reconciled all those issues, you should then be able to use this version of the project that you downloaded from GitHub. Android Studio's user interface is organized around the concept of windows. The primary window is the editor window. That's where you type your code. But there are many other tool windows available. You can open these tool windows in a number of different ways. From the menu, select View, Tool Windows, and you'll see an exhaustive list of all the windows that are available to you. You can also get to many of these windows using tabs that are wrapped around the user interface. By default, the Project tab is at the top left. There's a Commit tab where you manage your GitHub repositories, Pull requests for when you're working on a project with other developers and you're sharing development tasks, the Resource Manager, and so on and so forth. Most of these windows open and close when you click those tabs, so they're toggles. You can also close windows by clicking on the minus icon at the top right. You can get to many windows in another way. Move the cursor down to the lower left corner and hover it over this icon, and this menu will pop up. And many of these windows have keyboard shortcuts attached. So for example, on macOS, I can press Command 0, and that will open and close the commit window. You can move windows around the interface too. I'm going to click on the Structure window. This is a window that, when you're looking at a Kotlin or Java class, will show you all the members of that class. Now I'm going to drag and drop this tab and put it down here at the bottom. And now the Structure tab appears at the bottom of the interface. You can also click the gear icon for any of these windows, and you can choose Float, and now this is in a separate window. If you have more than one monitor, you can move this to another monitor. You can put the window back into the interface in a couple of different ways. Go to View Mode and choose Dock Pinned, and it'll pop back into that location. And then once again, I can move it back to its original location on the left side. So those are the tool windows. You have enormous control over the organization and appearance of the windows, and if there are some of these tool windows that you never use, you can remove them from the visual user interface. They'll still be available, though, whenever you need them. Android Studio is based on IntelliJ IDEA Community Edition, and it inherits the menus and toolbars organization that product has. In Android Studio, the default menu is based on a combination of the IntelliJ IDEA interface and custom features that are appropriate for Android. So for example, in IntelliJ IDEA, the Tools menu has AVD Manager and SDK Manager. Those are Android specific, and they don't appear in IntelliJ IDEA unless you're running the Android plugin in that product. Many of the items on the menu have associated keyboard shortcuts, and you'll see those keyboard shortcuts documented on the menu itself. You can also reorganize the menu if you like. Go to the Preferences or Settings dialog, to Appearance and Behavior, and then Menus and Toolbars. And this is where you would add new items, remove items, or reorganize the menu to your liking. There are a couple other toolbars that appear up here. This interface on the left side of the screen shows you the file and folder structure for your currently open file. So for example, I'm currently looking at main activity in the My First App directory under COM example. I can jump to any of these locations by clicking and then selecting and selecting again. If I close all the files, now I can go to my app module, then to source, to main, to Java, and so on. And then once again, I can open up my main activity class. The toolbar over on the right can be moved over to the left and expanded to include other actions. Go to the menu and choose View, Appearance, and select Toolbar. And all that functionality moves over, but you also now get actions for managing files: open, save, and reload from disk. If your current project has an associated Git repository, this toolbar will also show actions for managing Git, including updating the project, committing changes that you've made, pushing or uploading those changes, showing diffs, and so on. You'll also see that this is where you would launch your application, either by running it or debugging it. So those are the menus and toolbars in Android Studio. Again, you have enormous control over their appearance, and especially for this toolbar, you can decide whether it appears on the right in a limited form or over on the left with an expanded set of functions. Android Studio comes with a default set of keyboard shortcuts referred to collectively as the key map. You can see an exhaustive list of these keyboard shortcuts in a PDF file by going to the menu and selecting Help, Key Map Reference. This PDF document has 2 pages. The first page is the Windows and Linux key map, and the second page is all the keyboard shortcuts for Mac OS. Now, you can control these keyboard shortcuts and add your own custom ones. To do that, go to the Android Studio Preferences or Settings, and then select Key Map. Notice that there are many different built-in key maps available, and you can choose from one of these or you can create your own. I'm starting with Mac OS because I'm working on a Mac, and I'm going to click this gear icon and select Duplicate. The name of the new key map is Mac OS Copy. I'll press Enter to save that, and now I can start making changes. Let's say that I'm using GitHub branches a lot, and I just want to make it a little bit faster to open up the branches list. I'll go to Version Control Systems here, to Git, then I'll scroll down and I'm looking for branches. I'll select it, then I'll double-click on it and choose Add Keyboard Shortcut. Now I can press the keyboard shortcut that I want to use. If I choose a keyboard shortcut that's already assigned to some other action, I'll be told that right away. And if I want to override it, I can, or I can try another one. So I'm working on a Mac keyboard, and I'll choose Option and then the letter B, and that keyboard shortcut is clear, so I'll click OK to save it. And notice that that is now documented on the right side, and I'll click OK to save that. And now anytime I want to see my branch list, I can press Option and B, and the branches list shows up. As you use Android Studio, you'll find that you're using certain features a lot, and others not so much. And then you can customize the key map to create your own keyboard shortcuts for those actions that you use all the time. Android Studio gives you many ways of looking for your files. The simplest approach is just to go to the project window and then look for the file there if you know its location. So for example, my Java or Kotlin files will be under my base package under Java. But there are times when applications get so complex that you have very deeply nested folders, and it can take some time to look for a file that way. So here's a little trick. Press a Shift key twice. Notice this is documented on the screen, and it's called Search Everywhere. This dialog pops up, and you can start typing the name of any file in your project. So if I wanted to find a build.gradle file, I'd start typing build, and I'd see both build.gradle files, one for the module and one for the project. Then I can click or press Enter or Return, and the file opens. That same dialog has tabs at the top. You can search by class, by file, by symbol, by action, and there's also a section for Git actions. If you know for sure that you want to look for a class, you can press Command-O on Mac or Control-O on Windows, and you'll open directly to that Classes tab. And then you can start typing the name of the class. Once again, press Enter or Return, and the class opens. There's also extensive find and replace tools. These allow you to search by text values. These are under the Edit menu, under Find. If you select Find from the menu or press the keyboard shortcut, you're only looking in the currently active file. But you can also say Find in Files. When you find in Files, you can narrow your search by project, module, directory, or scope. I'll select Module, and then I'm selecting the myfirstapp.app module. Then I'll type the word main, and I see all the references to that word throughout all the text in these files. Then I can double-click and jump to that result. Finally, once you've found a file, you may want to find out where it is in your file or folder structure. You can do that by opening the file here, and then over in the project window, notice that I've closed up this tree entirely, and then I'll click this icon labeled Select Open File. And that opens the tree and shows you exactly where that file is located. If you're in the Android scope, you'll see where it's represented in this virtual tree. But if you're in the project scope, where you're seeing the raw file and folder structure, and then click that same icon, now you're opening the actual folder location on your hard disk. Those are some of the many ways you can locate your files, and then once you've found them, figure out where they're stored in your project. Android Studio projects use the Gradle build tool to build their applications. When you compile and package an application, Gradle looks at a set of what are known as dependencies. Dependencies are declared in a build.gradle file for each module. Each line of a dependency starts with an implementation keyword, or in the case of tests, test implementation or Android test implementation, and then is followed by a literal string. Literal strings that are wrapped in single quotes can't have any variable values in them. They include the domain that the package is from, the name of the package, and the version number. If you have anything in here that's outdated, Android Studio will suggest upgrades. So for example, if I change this from 1.4 to 1.3 and then resync, I immediately see a visual indicator that there's a more recent version. I can click into that string and then use an intention action and then change it to the most recent available version. The other way to do this is through the project structure dialog. Go to the menu and select File, Project Structure, or you can press that associated keyboard shortcut. From there, go to Dependencies, and then select the App module. In this interface, if there are any upgrades available to anything, you should see a squiggly line, and if you move the cursor over that, you'll see the message indicating what newer version is available. You can then select that dependency, pull down the list, and then choose the version that you want. In the case of the material design dependency, 1.4.0 is the most recent stable version, but notice there's already an alpha preview version. I'll go back to selecting 1.4.0 and click OK, and that change is made in the file, and the resync happens automatically. If you want to add a dependency and you don't know what the implementation string is, you can find it in the project structure dialog. Once again, I'll go to Dependencies and the App module, and this time I'm going to click the plus icon and choose Library Dependency. Now let's say I'm looking for the JSON library. This is an open source library from Google that lets you process JSON content. I'll type JSON and click Search, and then after a few moments I see that this dependency is available. I'll select it and click OK. It's added here in the project structure dialog. Then I'll click OK, and it's added in my build.gradle file. If I don't want that dependency anymore, I can delete it directly in the text file, or I can go back to the project structure dialog. If you make direct changes in the text file, remember to resync. So that's the basics of how dependencies work. The literal string is interpreted by the IDE, and then the associated library is pulled from a repository. And where is that repository? That's defined in the build.gradle file for the project. You'll see here what appear to be methods, Google and Maven Central, and these are declarations of locations of repositories where dependencies can pull their libraries from. In general, you just leave those the way they are, and if you see older applications that have JCenter instead of these two, that was an older Maven repository that's no longer being used. If you have one of those applications, upgrade JCenter to Maven Central, and you'll be ready to go. When you create a brand new Android Studio project, it'll have some dependencies in the app module's build.gradle file. These dependencies are typically declared as simple literal strings wrapped in single quotes. But it's pretty common to also use variables in your dependency declarations. Let's say, for example, that you had two related libraries that always were on the same version. You can declare a variable and then reference that variable with both dependencies. And then when you have to do an upgrade, you only have to change it once. There are a couple of different ways to set a variable. A simple way is in pure text by starting with def and then creating a variable name and setting its value. And then I could come down here and refer to that variable, starting with a $sign. I'll type KTX and then press Control Space, and I'll choose KTX version. Now, one wrinkle is that when you use a variable like this, you must wrap this string now in double quotes. That's why I'm seeing the warning indicator. But I'll use an intention action, and the first item on the menu is replace single quotes with double quotes. I'll choose that, and it's fixed. So that's one approach to creating the variable. But Android Studio can do some of the work for you. To do this, I'm going to open up an interface called the Project Structure dialog. It's available under the File menu. And I'll go to this Variables section. Notice that you can create variables in a few different places. I'm going to create the variable in my app module. I'll select New Variable. I'll give it a name of myVar. And then I'll give it a value of 2.0.0. I'll click OK. Then I'll scroll up here and I'll see some new code that's been added, an ext block for extensions, and then the name and value of the variable. And this variable is just as effective as the version that starts with def. Now, you'll also see these variables declared in the build.gradle file for the project sometimes. That's typically the best practice when you're working with an application that has multiple modules. It allows you to declare a dependency version once at the top level of the project and then refer to it in all the different module-specific build.gradle files where the dependencies have to go. Dependency variables give you a great way of making your application more maintainable. And again, you can use either of these syntax styles, the ext block or the def keyword, and you can place the variable declarations either in the same file where you have the dependencies, especially if it's a single module application, or in the build.gradle file for the project. I previously described how to use the project structure dialog to set certain values, to create variables, and manage your dependencies. But there are other configuration values in your Gradle build file that you can also set through the project structure dialog. To open that dialog, select File and then Project Structure, or press the associated keyboard shortcut. The first category in this dialog, Project, shows a couple of values that you're unlikely to change yourself from here. The Android Gradle plugin version has to match the version of Android Studio you're working with. But that's handled whenever you open up a project that was created in an older version of Studio. Android Studio will analyze the project and then will offer to upgrade the files for you. Similarly, the SDK location setting is where you tell Android Studio where your copy of the Android SDK is. Most developers have just one of those, and they don't move them around a lot, and so that's a value you're unlikely to change very often. I already described the use of the variable screen to create dependency variables, and that takes us to the modules screen. An Android project can have more than one module. A new project that's created in Android Studio typically has just one module named App. But if you want to create a new module, this is where you do it. In theory, you can also set the source and target compatibility of Java here. Notice here it says resolved JDK 1.8, and it says version 1.8 here. And if I go back to the Gradle build file, I'll see source compatibility and target compatibility both set to Java version and version 1.8. Now, this is where the project structure dialog doesn't always get it right. If I pull down this list of available Java versions, I only see 1.8, and that's even though the JDK that's bundled with Android Studio is Java 11. Now, I could try to change it manually here, and I'll do that. I'll put in Java 11 and 11, and my resolved settings go away. And if I click on this icon over here, I get a dialog, and that doesn't seem to help very much either. So I'm going to cancel out of this, and instead I'm just going to go back to my build.gradle file, and I'll change 1_8 to 11. And that's true for both settings. Then I'll resync, and now I'm able to use Java 11 syntax and some of the Java 11 APIs in my application. So the project structure dialog isn't perfect, but it does help. Let's take a look at one more screen, default config. This is where you could reset your application ID. Be careful with this one because then you'd have to go through and refactor your base packages everywhere too. But you can also set your version code, which is always an integer, and your version name, which is a string. There's also settings here for the minimum SDK version, the target SDK version, and so on. But again, those are typically set purely in the Gradle build file. The next screen is dependencies, and we've talked about that already. And the next category is build variants, and we'll talk about that feature of Android and Android Studio in a little while. When you're ready to deploy your application through the Google Play Store, you need to package it using a format known as an app bundle. Android Studio supports building both APK files in older format and app bundles. To get started with this process, go to the menu and choose Build, Generate Signed Bundle/APK. Here's the difference between the two formats. An APK contains everything that's needed for all Android versions and all supported devices. And that means that it can have multiple versions of resources such as image files and other files that can really bloat the package and make it take longer to download. An app bundle, in contrast, is structured so that individual APKs for particular devices can be created by the Google Play library. So when the user requests an application from Google Play, they'll be downloading an APK, but it will only include the content that's needed for their device. The result is a smaller file, faster download. Now, you still have to deal with APKs sometimes. For example, if you're deploying and publishing on Amazon, at the time of this recording, Amazon only supported APK files. But Amazon has recently announced that they're going to start supporting app bundles in the future, so stay tuned for that progress. So, here's how you create an app bundle. On this dialog, choose Android App Bundle and click Next. The first step here is to create something called a key store. This is a file that contains a certificate or key. I'll click Create New, and then I'll browse to decide where I'm going to put the file. I'm going to put it on my desktop so that it's easy to find. And I'll name it My Certificate, and I'll give it an extension of JKS. I'll click Save, and that actually creates the file. Next, I need to enter a password twice. This part is very important. You have to remember this password. If you forget this password, this certificate won't be usable anymore, and you'll have to start over. So whatever password you set, write it down, put it in a safe. Make sure you can find it later on. Next is an alias, and this can be any string. I'll call it my alias. And then another password. This can either be the same password as your main key store password, or it can be different. Next, set the validity, and the maximum is 25 years, and enter either your name or an organization name. And once again, those values can't change once you've created your first version of the application. Don't forget these values. Write them down. Click OK, and come back to this primary dialog. Now, if you're going to export to Google Play, you'll want to select this option to export an encrypted key. And if you're going to be doing multiple builds, I recommend remembering the passwords. Click Next, then select which kind of package you want to create. If you're creating a signed bundle for publication, choose Release. Then click Finish, and wait for a few moments. The first time you build the application, it might take some time while everything is gathered together. But then, when it's all done, you'll see this notification. Click the notification, and you can click Locate to find the app bundle. If it was a release bundle, it'll be called apprelease.aab, and it'll be under a release directory. And I had said I wanted to put everything on the desktop, so that's where it ended up. And notice on the desktop, there's also a file called privatekey.pepk. This is a private key file. And the first time you deploy this application to Google Play, you'll need to upload both the AAB file, that's the app bundle, and the private key. Once you've published the application for the first time, every subsequent upload will only need the new AAB file. Google Play will store and reuse the private key for future deployments. So those are the basics about creating app bundles for deployment on Google Play. And again, this process will also apply to deploying on Amazon in the future. The Android SDK gives you the ability to create multiple versions of an app, with each version of an app designed for a particular scenario. Now, this is very flexible, and it depends on how you're going to deploy the app and what each version is for. But the idea is that these different versions have a shared code base, and then they have distinctions between them. And the distinctions could be different app IDs, different code paths, or even different versions of a library, such as in-app purchasing. These are called build variants. And you'll see that there's a build variants window and a tab down in the lower left corner to get to it. By default, a new app has two build variants, a debug variant and a release variant. But you can define your own dimensions, that is, how you're going to define the variants, and then within dimensions, you can define multiple flavors. You define these in the build.gradle file, but the project structure dialog makes it easy to set up. So I'll go to the menu and choose File, Project Structure, or press the appropriate keyboard shortcut. And I'm going to the Build Variants section here. Now, over here, I've selected my app module, and I've selected the Flavors tab. I'll click the plus icon and say I want to add a flavor dimension. Here's the scenario I'm going to work with. I have an app, let's say, that's designed to be deployed on Google Play. But now I also want to deploy that app on the Amazon App Store. And there are going to be different requirements. On Google Play, I might use in-app purchasing, which would require the use of the Google Play Services library, while on Amazon, in-app purchasing would go through their library. So I'm going to create a new flavor dimension, and I'll call it App Market. And this is lowercase, and I'm using an underscore character instead of a space. Now with my new dimension selected, I'll click plus again, and this time I'll add a product flavor. The first one will be Google. Then I'll add another product flavor, and this one will be Amazon. For the Google flavor, I'll leave all these settings blank, and that means I'm using the default settings in my build.gradle file. For Amazon, though, I'll make one little change. I'll add an application ID suffix of .amazon. And now whatever the base application ID or base package is for my app, the Amazon version will have an extension. And that'll make it easy at runtime to identify which version of the app is being run. I'll click OK, and then I'll open the build.gradle file for the app module. And this is what the code looks like. Under flavor dimensions, I have one value, app market, and then under product flavors, I have two, Google and Amazon. They both declare the dimension of app market, and Amazon also declares the application ID suffix of .amazon. Now if I look at the build variants window, I see that under the active build variant, I can choose Amazon Debug or Release, or Google Debug or Release. Now, if I want to run this app on a device, whether virtual or physical, I would first choose which build variant I'm working with, If I'm debugging, I'll choose one of the debug variants, and then that's the version that I'll install on the device. When I package the app for deployment, I'll use a signed app bundle or APK. And I'll go through the process to create those. I've already created my certificate and I saved my password, so this step is easy. And on this screen, I now see the option to select the versions that I want to create the APK or bundle for. I can hold down the Control or Command key, depending on whether I'm on Windows or Mac, and then select the ones I want. And when I click Finish, I'll generate multiple packages or APKs. Once you've defined your build variants, you can distinguish the different versions from each other in a lot of different ways. Because I have a different app ID, as I mentioned, I can identify the version I'm running at runtime, and I can create different versions of image files, menus, string resources, and anything else that goes into building the app. So you can have the bulk of your code that works the same for all versions of the app, and then you can distinguish the variants either visually or with different functionality. Build variants give you an enormous flexibility in how you structure your app to deliver different versions depending on whatever scenario you need to satisfy. Each Android app has a primary programming language of either Java or Kotlin, but regardless of which language you're using, for most Android apps, you can create new files in either language. To create a new file, first go to the package where you want to create the file. Do this in the project window, and if you're creating the file in your base package, you can create it here. Or if you want to create a new package, you can create it by right-clicking and choosing New and then Package. I'll create a new package named Utilities. Then I'll right-click again and choose New, Kotlin Class or File. Kotlin files come in a lot of different flavors. A class will have a class declaration, a file will just have top-level declarations, and you can also create interfaces, sealed interfaces, data classes, and many other types of files. I'm going to create a class that I'll call MyClass. Each time you create a file, if your project is attached to a Git repository, you'll be prompted to add the file. And now it'll be tracked by Git. Within the class, I'll create a new function that I'll name SaySomething. Now to autocomplete, I held down the Command and Shift keys on Mac, or the Control and Shift keys on Windows, and then pressed Enter or Return. And for a function, that would result in adding the braces. There are many other ways you can use that autocomplete feature. Now within the SaySomething function, I'm going to type log D. This is something called a live template, and I'll get into these in a little bit more detail later, but it's basically an abbreviation, and when I press the Tab or Enter or Return key, it'll expand into something. Now in this case, log.d is looking for a string constant named tag that doesn't exist yet. But let's first complete the rest of the code. Notice that there's a cursor blinking and a little placeholder there, and I'm going to type hello exclamation and then press Enter or Return, and that placeholder goes away. Now I'll come back to this tag constant, and this constant doesn't exist in my code yet. If I use an intention action to try to autocomplete it, I'll see that there isn't really anything useful there. So I'm going to place the cursor up here at the top of my class, and I'll type con for constant, then tab to complete const val, and in Kotlin that means create a constant. And I'll create a tag, and I'll call it my tag. And now that error condition down here goes away. Now I'll come back to my activity, and I'll create a new instance of my class. I'll say val my class equals my class, and I'll add the parentheses, and that means I'm creating an instance of the class. And then I'll call my class.saySomething, and notice that as I'm typing, everything is being auto-completed for me. Now I'm going to run the app in a virtual device. I'll choose my fake Pixel 3a that's running on API 30 or Android 11, and I'll launch, and that'll start up the virtual device. And then after a few moments, I'll see my app is being run. Now I'm going to look at the logcat output. I'll click on the logcat window down here. I'll make sure I've chosen the correct device from this pull down, and then I'll filter on my_tag, and I say something hello. So Android Studio helped me create the file and its basic structure as a class. It auto-completed a lot of the code as I typed it. A live template helped me fill in this code, and when I came back to the main activity to reference that class, Android Studio knew about the class and helped me auto-complete this code as well. So the goal of Android Studio is to help speed up your code and make your application more accurate and easier to maintain. This ability to create new files and then complete the code as quickly as possible is a key to that capability. Android Studio has many keyboard shortcuts that you can use to speed up your programming. You can learn about them by going to the Help menu and choosing Key Map Reference. That will open up a PDF document in the browser, and there's one page for the Windows and Linux key map and one for the Mac OS key map. Here are some of my favorite keyboard shortcuts. First, you can quickly comment and uncomment code. I'll select these 2 lines of code, and then I'll press Command and / on Mac or Control / on Windows. And this is a toggle operation. When I first press the keyboard shortcut, I'm commenting. When I press it again, I'm uncommenting. You can also use keyboard shortcuts to auto-complete your code. Let's say, for example, that I want to create a variable and declare its type. I'll start with val, myvar, and then a colon, and then I'll type int. And there are a whole bunch of classes in both Java and in the Kotlin core libraries that start with that string. I can type more of the type, and then when I find it, I can press the Tab key, and it'll be auto-completed. If I were working in Java, I could then auto-complete the rest of that code by pressing Command-Shift-Enter or Control-Shift-Return, and that would add the semicolon at the end of the line. Here's another variation on this. I'll create another variable that I'm going to name intent, and then an equals operator, that's the assignment operator. Then I'll press Control-Shift-Space, and that's the same keyboard shortcut on all operating systems. And this is called Smart Code Completion. It filters the list of identifiers based on the string that you've already typed. And if I say I want to assign this from the parent property, and that's the equivalent of calling the getParent method in Java, I could then press Enter or Return, and that would complete the code. You can also easily move code around in either Java or Kotlin files. To move a single line of text up or down, place the cursor on that line, then press Option or Alt, then the Shift key, and then up or down. And there's the result. Now let's say that you had blocks of code that you wanted to move around. I'll create 2 functions that I'll call myfunc1, and I'll autocomplete that, and then myfunc2. Now I want to move the entire function up or down. I'll place the cursor anywhere in the block, then I'll hold down the Command or Control key, depending on operating system, and the Shift key, and when I press up or down, I'm moving the entire function. Now to duplicate lines of code, press Control on Windows or Command on Mac, and then the letter D. I'll take out this line, I'll select these 2 lines of code, and then Command D on Mac or Control D on Windows. And then I'll add an extra character to these 2 identifiers to make them different from the original. To delete lines of code, press the Command key and backspace on Mac, or Control and Y on Windows. There are many, many more tricks you can learn for working with your code in Android Studio. And again, for some hints, I recommend looking at the default key map reference for your operating system. Android Studio has powerful refactoring capabilities, letting you rename your symbols, move files around, and also extract code into new factors. I'll show you how to use some of these features in this project, and I'll start with renaming variables. To rename a variable using refactoring, place the cursor in the variable name anywhere, then press Shift F6, and that's the same keyboard shortcut on all operating systems. You'll see a box appear, and then you can start typing a new name. So let's say I wanted to change the variable my class to my first class. As I type the name in one place, it will update in the other. Then when I press enter or return, that change will be committed. Now you can do the same thing with class names. I'm going to jump to my class, and I did that by holding down the Command key on Mac or Control on Windows and clicking the class name. Now once again, I'll place the cursor inside the class name and press Shift F6, and I'll rename this as my first class and press enter, and the change is saved. Now notice something interesting. When I changed the name of the class, that also changed the name of the file, and that's going to be true for both Kotlin and for Java. You can make the same change starting in the project window. I'll click on that class in the project window, press the keyboard shortcut, and a dialog pops up, and notice all the options are checked to search for references and comments and strings. I'll change this back from my first class to my class. I'll click Preview, and I see a listing of the changes that are going to happen. And then I'll click Do Refactor, and the change is made here in the file, but notice this time the class name itself isn't changed in the code. If I were in Java, it would have been, because in Java the name of the class has to match the name of the file. I'll refactor again here, change this from my first class back to my class, and that work is done. You can also refactor from the menu. I'll go back to my main activity class, and I'm going to click into this variable. I'll select Refactor, and notice Rename is here, and that's what we've already been using. And you can also do a rename of a file from here. You can also select Refactor this, and you'll get a menu showing all the different options for changing your code. Let's say, for example, that I wanted to take this bit of code and extract it out to its own function. So I'll select those two lines, then I'll go to the menu and select Refactor, refactor this, and under here, under Extract Introduce, I'll say that I want to extract to a function. If it were Java, it would say method. I'll select that. I'll change this to say something. I'll click OK, and that code is extracted to a new function, and a call to the function is inserted in its place. There are many other ways to refactor your code. Go to the menu and select Refactor and refactor this, and try some of these features. Moving classes from one package to another is another form of refactoring. So I'll come back to my project window, and I'll right-click here and create a new package, and I'll call this util instead of utilities. Then I'll right-click on the class and choose Refactor this time. This is just another way to get to these features. And this time I'll select Move Classes. In this dialog, I can click the three dots button and browse. I'll select Util, and then Refactor, and the class is moved. And notice that the package declaration is fixed to match the move. So renaming, moving, and extracting code are all forms of refactoring, and they're all available within Android Studio. Android Studio has something called live templates. A live template is essentially an abbreviation that can be expanded to some boilerplate code. Here's an example of a live template that's already built into the product. I'll type logd, and then I'll press the tab key, and that expands to the log.d function call. This is a function that outputs something in what's known as the logcat window, and it's how you would trace what's going on internally at runtime in an Android app. You can modify the existing live templates and create your own. So I'm going to get rid of this code that was generated, and then I'll go to the Preferences dialog on Mac or Settings on Windows, and look under the Editor category and look for Live Templates. All your live templates are separated in this interface into categories. Anything under the Android category will be coded in Java, not Kotlin. So notice that there's a const live template there. But there's also a section called Android Kotlin, and it has a lot of the same functionality. Similarly, there's an Android Comments, that's for Java, and an Android Comments Kotlin, and that's for Kotlin. The live template that I demonstrated, logd, is under Android Log Kotlin. and you'll find that there are templates for all the different functions of the log class. Let's say that I wanted to change the way this template behaved so that instead of creating a tag label, I wanted to change it to something called log tag. I can make that change right here, then click Apply or OK, and then I'll try it again, and this time it expands to log tag. Now let's say that you wanted to create your own live template. Once again, I'll go to Preferences or Settings to the Live Template screen, and I'm going to place my new live template under Android Kotlin. It doesn't really matter where you put it. And then I'll click the plus icon and say I want to create a live template, and I'm going to name this Clip. And its goal is to output the contents of the clipboard. For the template text, I'll say // clipboard data. And then let's say that I wanted to output the contents of the clipboard. I'll create a new variable, starting with a $sign, and then after some string, another $sign, and that declares a variable. And this button now becomes alive. I can click Edit Variables, and I can change this to an expression. When I pull this down, I see a list of all the values that Android Studio can pull automatically. I'll scroll down here and I'll choose Clipboard. I'll click OK. And then I have to assign a context. Android Studio will only activate a live template when it's assigned to the current context. I'll click Define. And I could say it's for everywhere, but instead I'm going to be specific. I'll go to Kotlin, and then Statement. And now this is only going to work when I'm working in Kotlin. I'll click OK, and then I'm going to copy something to the clipboard. I'll select this, right-click and copy. Then I'll type clip. I'll press Tab, and you see the literal value, clipboard data, and then the value of the clipboard. I'll do that again. I'll copy this time. Once again, I'll type clip, press Tab, and there's the result. You can get as creative as you like in creating your own live templates or customizing the templates that are included when you first install Android Studio. Android Studio has tools that are dedicated to supporting visual design of your application. In conventional Android apps, your application's visual presentation is determined by XML layout files that are stored in the Layout directory under Resources. You can open these files in a couple of different ways. If you know the name of the file, you could use the Search Everywhere feature by pressing the Shift key twice, and then you can start typing the name of the file you want. You can find the file in the Project window, or if you're working in an activity or a fragment class that references an XML layout file, you can hold down the Control key on Windows or the Command key on Mac and click the reference. You might see the XML layout file referred to through its resource ID, starting with r.layout, or as is the case here, you might have an automatically generated binding class that was built from the XML layout file, and you can Control or Command click to get to the file this way as well. Regardless of how you open the file, by default, it normally opens in Design View. But you can switch back and forth between Design and Code View by clicking the buttons at the top right. That's the XML view, and that's approximately what the XML layout file will look like. Now I'm going to close the project view to get a little bit more space here, and then show you that you can also look at this in split view so you can see the code and the visual design right next to each other. When you're working in Design View, you'll have a palette over on the left, and you'll see categories and then controls. If you wanted to drag in a component, you simply click, drag and drop, and place the object on the screen. Now, assuming that your layout is using a constraint layout, you can then constrain the object to the edges of the layout. You can do that by clicking and dragging. I've now linked that button down to the bottom of the screen. Or you can do the same thing over here in the Attributes window, where you can click on these plus icons, and then you'll be adding the anchor, but also margins. I could change these margins here. I'll change it to 8, 8, and 8. And then I'll look at the resulting code, and I'll see that the button was added with these 3 margins already set for me. I'll go back to Design View and show you a couple of other things. There are 2 views of the layout file. You can choose which of these views you prefer by clicking on this pull down, and you'll see that right now I'm showing both the design and the blueprint view. If I only want the design view, I can choose that, or I can choose just the blueprint view, or I can go back to both. You can also resize these views. There's a plus button, a minus button, and a fit the window button. There are many other icons up here. You can actually change the orientation for previewing. I'll switch from portrait to landscape. Then I'll switch back again to portrait. But you can also use this menu to create new versions of your layouts. I'll select Create Landscape Variation, and that creates a new directory for layouts in landscape mode. And because it's a new file, I'll add it to my GitHub repository. Now I'll go back to my project window. I'll switch to the project scope. Then under App, I'll go down to Resources and show that this new layout land directory was created for me. And here's the file that was created. You can also decide what kind of device you want to look at the layout in. This menu will have items for all of the virtual devices that you've created. I've created a Pixel 3a, a Nexus 9, and a Pixel 4 virtual device. But you can also choose from any of Google's standard Nexus or Pixel phones. So for example, if I wanted to see what this application might look like on a tablet, I might choose a Nexus 9. And now I'm looking at it in a tablet form. You can also choose which version of Android or which API level you're using for preview. And you can also set different themes. There's a couple other items down here. For example, this button is used to set default margins for when you add new items to the screen. And this one is used to add more advanced functionality that's supported by the constraint layout container. So that's a brief look at the XML layout editing environment. It gives you lots of great tools for quickly creating XML layouts and then previewing them to see how the layouts will look on various devices. Starting in 2019, Google declared that Android from that point forward would be what they called a Kotlin-first platform. And that means that most new Android apps are being built with Kotlin, but there's a lot of older code out there that was built with Java, and sometimes there are mixed development teams where some people work best in Kotlin and others in Java, and you have to convert back and forth. The good news is Android Studio can automatically convert your older Java code into Kotlin. To demonstrate this, I'm going to create a new activity in my base package of this app. And if you're following along, you can do this in any Android app. I'll right-click on the base package and select New, and then I'm going to create a new activity. And I want some pretty complex code, so I'm going to choose a basic activity, and I'll use all the default names, main activity 2, and so on, and then I'll click Finish. And I'm doing this in Java. And this results in creating a number of new files, including 3 files with a .java extension. After I create that new activity, it'll take a few moments while the app is rebuilt. Now, I'll show you a few different ways where you can use this feature. First of all, let's say that you had some Java-based code that you liked and you wanted to add it to a Kotlin-based file. I'm going to select 3 random lines of code that are written in Java. And for this demonstration, it doesn't matter what they do or whether they're actually going to work right away, and I'll copy them to the clipboard. Then I'll go over to this activity, which is built in Kotlin, not Java, and I'll paste that code in. Android Studio detects that I've added some Java code, but I'm in a Kotlin file, and it asks if I want to convert it. And I'll say, yes, I want to do that. And there's the result. That code is automatically rebuilt in Kotlin. Now, this code doesn't work in this particular activity, so I'm going to undo that by pressing Command or Control-Z. That's the undo keyboard shortcut. And instead, now I want to take an entire file and convert it from Java to Kotlin. I'll click on this file and then click on the icon to go to that file in my tree. I'll right-click on it, and down at the bottom of the menu, I'll select Convert Java File to Kotlin File. The amount of time this takes depends on the complexity of your code. In a short file like this, it just takes a moment, and then I see a confirmation dialog. I'll say, yes, I want to make the change, and if there are any references to this file anywhere else that need to be changed, I want Android Studio to do that too. I'll click yes, and now my file has been rebuilt in Kotlin. I have two more Java files. I'll select this one, and I'll right-click again and choose Convert Java File to Kotlin File. Once again, I'll say, yes, I want to make the change. And now my first fragment file is in Kotlin, and so is my second fragment. So you're not limited to doing one file at a time. You can do bulk conversions. After you do this sort of conversion, you'll typically have some cleanup to do. For example, this conversion process doesn't always get nullability correct. In this example, the onCreateView function says that it's returning an instance of a nullable view object. But Android Studio determines correctly that that may not be right, and so it gives you a warning indicator. If I place the cursor after that question mark, I then see that there's a suggestion to make it not nullable. I'll accept that, and the question mark is deleted. You also might need to go to certain variables and change how they're declared in Kotlin. For example, after the conversion, this binding object was declared as null. My preference is to use what Kotlin calls a late init variable. So I'll add the keyword late init before var, and now I don't need to say that it's nullable, because the nature of a late init var is that it will always be initialized at some point. Then I can come down here to the double exclamation mark, which is an assertion that something isn't null, and I can use an intention action wherever I find that and get rid of it. And then down here, I can say, well, I don't need to make the binding null anymore, so I'll get rid of that line of code as well. When you clean up converted Kotlin code, a lot of times you're removing code you no longer need. Now that I'm not doing anything custom in the onDestroyView function, I can delete that as well, and now I'm depending on the superclasses version of that function. A conversion from Java to Kotlin code can result in a lot less code, and code that's a lot cleaner and easier to maintain. Android Studio has tools that let you inspect your code, and it'll report issues. There are a few different ways to do this, but I'm going to start with the True Analysis tool. Now, in my previous video, I made some changes that resulted in leaving behind some problems. One approach to finding those problems is to go to the Problems window, where I can see that there's an unresolved reference and an unused import directive. But another approach for finding more subtle issues is to go to the menu and choose Analyze, Inspect Code. In this dialog, you can indicate the scope of the inspection. You can inspect the entire project, just one module, only files that haven't been committed to a GitHub repository, one file at a time, or your own custom scope. I'm going to choose my current app module and click OK. The amount of time this takes will depend on the size of your project. A very small project like this one will be very fast, but a more complex application might take a few minutes. So let's go through the issues that were found. For each issue, you can double-click in the inspection results window, and you'll jump to where the issue happened. Then in most cases, you'll see an error indicator in the form of background coloring on a font, and when you move the cursor over that error indicator, something will pop up telling you what's going on. In this case, I have a default allow backup attribute in my manifest set to a value of true, but I haven't done all the other work that would be needed to make that work. So I'm going to change that from true to false, and after a moment that goes away. Now I'll go to my Kotlin section, and I see something called a redundant construct, an unused import directive. And this resulted from the refactoring operation I did in a previous video. Now I could just delete that line of code, or I could do something called optimizing imports. I'll go to the menu and select Code, Optimize Imports, and my imports are cleaned up for me. If I have imports I'm no longer using, they'll be deleted, and the imports will be resorted alphabetically. The next thing I see is something called proofreading, and I'll come down here and go to this file, and I see that there's a warning that there's a typo in the word My First App. Now, that's not really a problem because that's not meant to be something that somebody would read, but I could rename that package if I like. Alternatively, I could click on More Actions, and I could save that string to a dictionary. And the dictionary will be a new file that is now part of my project, and I can check that file into GitHub. After I've gone through all the issues, I can reanalyze, repeating the operation and inspecting again. And if nothing's wrong, I'll see the message No Suspicious Code Found. And again, for the most obvious sorts of coding problems, you can use the Problems window, and it'll show you things like bad syntax, unresolved variable references, and so on. Android Studio, which is based on IntelliJ IDEA Community Edition, has all these tools to make your code more robust and bug-free. As your Android Studio projects get larger and more complex, recompiling and building them takes longer. Android Studio has a great tool that lets you apply little changes to your project while you're running them on a device, either virtual or physical. To demonstrate this, I'm going to create a new project, and I'm going to base it on the basic activity template. The language is Kotlin, and the minimum SDK is API 21, and I'll just name this Basic App. Now I'm going to run this on a virtual device, and I'm using a virtual device that mimics the Pixel 3a or API 30. When the app first opens, it displays a fragment which has a text value saying Hello First Fragment. Now let's look at the code that's making that happen. I'll go to my first fragment.kt file, and then I'm going to Control or Command click on the binding for this XML layout, and then look at this in code. And I see that there's a text view here with a text value of Hello First Fragment and an ID of text view first. I'll come back to the fragment, and then I'll go to the onViewCreated function down here. I'll call binding dot, and then that text view object's ID gets turned into a camel case variable name, text view first, and then I'll set text, and I'll set that to a value of Hello Android. Now I'll run the application again. Notice I'm clicking on this button up here, and I'll terminate the application and restart it from scratch. Now the text value says Hello Android. Now let's say I want to make a really small change. I'm going to change this from Hello Android to Hello from David. There are two more buttons up here on the toolbar. The first says Apply Changes and Restart Activity, and the second says just Apply Changes. Now, if I just apply code changes, I won't see any difference. And that's because just applying the changes won't recall all these lifecycle functions like onViewCreated. To see this change, I'll need to apply the change and restart the activity. So I'll click this button, and now I see the updated value in the text view. Now let's make another more extreme change. I'll take this string of Hello from David, and I'll use an intention action, and I'm going to extract a string resource. And I'll give it a resource name of Hello from David. Resource names or IDs have to be lowercase with no spaces. I'll click OK. Then I'll Control or Command click to jump to that string, and I'll change this to Hello from me. If I try to click Apply Changes this time, I'll see an error saying the changes weren't applied. Whenever you change a resource, either adding, removing, or altering, you must restart the activity at least. So I could come up to the toolbar and click this button, or I could click this link in the error notification. And I see the message Hello from me over here. So those are your three options. You can restart the entire application from scratch, and if you're already running the application, you'll be prompted to terminate the current session. Or if you make a change that requires an activity restart, you can just restart that activity but not reload the entire application. Or if you're making really small changes, that don't involve changes to resources or new classes, you can click on the Apply Code Changes, and that will happen immediately. The Android SDK's log class lets you create and send messages from inside the application to help you trace what's going on internally at runtime. These messages are received in the logcat window in Android Studio. And if you have a device connected to Android Studio through ADB, you may see a constant stream of messages being sent. When your app is sending its own messages, you'll want to be able to filter those messages. Now, I'm going to show you a very common pattern that a lot of Android developers use on Kotlin-based apps. First, I'll go to the project, and I'll go to my base package here, and I'm going to create a new Kotlin file, and I'll name it constants. This will be a file, not a class. And within this, I'm going to create a constant with const_val. I'll give it a name of tag, and I'll give it a string value of my app tag. Now, that string could be anything you like. The reason I'm naming this constant tag is because the built-in live templates for logcat output assume that that's going to be the name of the tag. Now I'll go to the main activity class. In the onCreate function, I'll call logd. I'll press tab, and notice that I changed this earlier to log tag, so I'm going to change that back to tag here. And then for the message onCreate, I'll put in main activity. Now I'll copy that statement, and next I'll go to my two fragment classes. First to firstFragment.kt, and then in onCreate view here, I'll paste this in. I'll change this to onCreate view and first fragment. I'll copy that. Now I'll use search anywhere, and I'll look for second. I'll go to second fragment KT. And then in the onCreate view here, I'll paste this in. And I'll say that this is the second fragment. Then I'll restart my application. As the app opens on the device, each of these lifecycle functions will be called, and my log statements will be called. If I go to logcat and look at all the messages, I'll see a whole bunch of stuff that isn't my application talking to me. So to filter this, I'll go back to constants.kt. I'll select and copy that string. Then in the logcat window, I'll paste it, and now I'm seeing just my messages. Now I'll go back to my application in the emulator. I'll click the next button, and now I'm on the second fragment, and then I'll come back to the first fragment, and each time I move from fragment to fragment, I'm seeing new messages. You can also use this filtering to locate and inspect errors that happen. When a crash happens on an Android device, the error messages that appear in logcat will have a tag of Android runtime. You can use this string as a filter, and then you'll see the error stack, and you'll be able to diagnose what went wrong when your application crashed. Notice that you can also use regular expressions in this window. You can filter based on the level of the issue. For example, if I want to go back to my original tag, I can pull down this list and choose my app tag. And right now I'm seeing my messages, and I'll see those as long as I'm filtering on verbose or debug. Those are the most permissive levels. But if I filter to a higher level of warning, those messages will not appear. So the logcat window, along with the log class and all of those live templates that are available in Android Studio to quickly set up those tracing messages, let you easily find out what's going on inside your application at runtime and diagnose issues. One of the most important tools that you need in a good integrated development environment is a debugging tool that lets you set breakpoints so you can suspend operations while the application is running, and then during that suspended breakpoint, inspect variable values. To demonstrate this, I've set up a little bit of code in this onCreate function in this main activity class. If you're following along with your own code, you can use any Android app for this. Now, I want to take a look at the value of the color variable while I'm doing this loop. So I'm going to set a breakpoint, and I'll do that just by clicking right next to the line number here. Now, this is the most simple of breakpoints. It basically says, when I get to this line of code, stop. suspend before I execute it. Now to run this with breakpoints, I'll go to my toolbar and I'll click on Debug App. If you simply run the app, the breakpoint won't be respected. When I get to that line of code, the app will be suspended, and now I can look at all the different values that are available in the application. So for example, I can see that the value of the color variable right now is red, and over here I'll see buttons that I can click to either resume the program or stop it. There's also a button here for viewing my breakpoints, and I can see what breakpoints are available, and there's all kinds of conditions you can set. Now I'll get out of that dialog, and I'm just going to step through my code a little bit. First I'll say resume program, and that means keep running the loop, and that means I'll hit the breakpoint again. And now the value of color is green. I can also step through one line at a time by clicking on the Step Over button, or pressing the associated keyboard shortcut F8. And now because I'm stepping one line at a time, I'm hitting everything, not just the line with the breakpoint. For more complex values, you can click down here and then open up the tree, and this is a list of strings, and I can clearly see the indexes and the values. Now I'm going to stop the app, and then I'll run it in debug mode again, and I'll hit that breakpoint again. In addition to inspecting values that are displayed down here, you can also evaluate arbitrary expressions. So for example, I'll select this, and then I'll right-click, and I'll say Evaluate Expression, and then I'll make this a more complex expression with mylist.size. And then when I click Evaluate, I'll see the result of 3, meaning there are 3 items in the list. You can evaluate very complex expressions this way. Android Studio is taking that expression and packaging it and then running it through the Java virtual machine in the background. You can also switch between different languages here. So for example, if I choose Java, I won't be able to evaluate that expression because that's a Kotlin expression. So the ability to use breakpoints to suspend operations while your application is running, and then to look at the values of variables while you're in that suspended mode, is an incredibly important tool for debugging your Android apps. As Android Studio has evolved, it keeps on adding new, great tools for inspecting what's going on inside your application at runtime. One of these is called the App Inspector, and I'm going to demonstrate one of its features by creating a new application based on a sample app from Google. From the Welcome screen, I'll choose the Options menu, and then choose Import an Android Code Sample. And I'm going to type in Room. That's the name of the library for building and managing SQL-like databases. I'll choose Architecture Components Basic. I'll click Next and Finish, and that will download the application to my installation of Android Studio. Each of these samples has a markdown file that you can look at to see what it does and how this application is put together. The important thing about this application, though, is that it will generate an SQL-like database on the Android device. And then we'll use the App Inspector to look at the contents and even change the contents of that database at runtime. Each time you download one of these samples, it's very likely that you'll have to update it for your version of Android Studio. So once the project has been built and all of the components downloaded, you'll see a prompt, and you'll want to accept that prompt to upgrade. I'll click on this link to upgrade, and then click Begin Upgrade. And then in this screen, I'll click on Run Selected Steps. And then after a few moments, this app will be ready to run on my device. So I'll get rid of some of these messages in Windows, and I'll open up my emulator. And now I'm ready to run the app for the first time. Once the app is up and running, I'm going to click on the Search Products text box, and I'm going to type the word monkey, and then click the search icon, and I see a whole bunch of data values. Now, all these values are being stored in an SQL-like database, and I want to look at that database's contents. I'll click on the App Inspection tab at the bottom. If you don't see that tab, you can go to the menu and choose View, Tool Windows, and App Inspection. After a few moments, you should see that your process is selected, and then down here, you'll see a list of all the tables in your database. I'm going to choose the products table. First, I can open up this tree and see its structure, and then I can double-click it, and now I'm actually seeing the data inside the table. Notice this first line says Special Edition Three-Headed Monkey, and then I'll expand this so I can see more of my device, and there's Special Edition Three-Headed Monkey. Now let's say you want to make a change to that data. You can actually do that at runtime. Make sure that the Live Updates option is unselected for this. Then double-click into a value and change this from three-headed monkey to three-headed donkey. And then watch what happens up here when I press Enter or Return. Instantaneously, the app is updated. And that's because this application is using the architecture components or Jetpack libraries so that it's observing the data in the database. Each time the data changes in the database, it's being observed by a live data object, and then the observing code in the UI is seeing the change and updating what the user sees. So that's one approach to using this app inspector. You can also turn on live updates, and then these values in the inspector tab will be updated in the other direction. If you do something in the application that changes the data there, then that new data will be shown here. If you're in live update mode, you can't edit though. And if you're editing, you can't be in live update mode. It's one or the other. So those are the basics of the database inspector. This window also has something called a background task inspector, and it's specifically designed to inspect what's going on when you're using the Work Manager API. Both of these inspector tools are incredibly valuable for seeing what's going on internally in your Android app when you're running it on an Android device. Android Studio has a great tool called the Profiler that lets you inspect how an app is using various resources, such as memory, CPU, and network traffic. To demonstrate this, I have this application called the Memory Eater. This is the latest version of this application, built for Android Studio 2021, and it's available through this GitHub repository. I'll copy the URL for the repository, and then in the Android Studio welcome screen, I'll click Get from VCS, I'll paste that in, and I'll clone the project to my development computer. And when prompted, I'll say, yes, I want to trust this Gradle project. If this is the first time you've run this app, it might take a few moments to download all of the required components. But while that's happening, let's take a look at some of the code. There's a main activity class, which uses a view model, and in the view model, there's some code that does an infinite loop and adds thousands and thousands of objects to a collection. The goal here is to use as much memory as possible. In the main activity, there are some event handlers for two buttons called the Eat button and the Release button. The Eat button starts the memory eating process, and the Release button releases the memory and stops the infinite loop. You can inspect the code here to see exactly how it's working, but the most important thing to know is that as this loop is executing, it's periodically reporting how many items are being stored in the collection. And then in the Release Memory function, the loop is broken and the data is cleared. I'm going to run this application on my virtual device. Notice up here, the message says ready. I'll click Eat Memory. And now I'm adding lots and lots of items to that data collection. When I click the Release Memory button, the number of items goes back to 0. Now let's see what that's doing to memory usage. I'll click on the Profiler window down here, and then I'll add a new session, and I'll choose Google Pixel 3a API 30, and this may have already been selected automatically for you. Now I'm going to expand the size of this, and so I can see exactly what's happening. And I see that there are categories for CPU, memory, network, and energy. I'll click on memory because that's what I'm really interested in. And right now I see that memory usage is pretty constant. Nothing's really happening. Now I'll click here to give focus to the virtual device, and then I'll click the Eat Memory button. Up here, it's a little hard to see, so I'm going to expand this a bit. You can see the number of items in the collection is growing. And then down here in the memory profiler, I can see the amount of memory that's being used is also growing. Periodically, there might be a jump in memory usage, or there might be a cliff. And that cliff is when a garbage collector event would have happened. Notice here, there's a garbage collector icon that's traveling with the timeline. You can place the cursor anywhere on this timeline and see where the memory is being used. And I can see here clearly that the memory that's changing is in the Java-based memory management. There are other tools here, including the ability to capture your heap dump, record your native allocations if you have any native code in C or C++, and recording your Java and Kotlin allocations. If I click on Record Java and Kotlin allocations and then click Record, I'll then see this report of exactly how much memory was allocated to various kinds of objects. And here I can see that there are thousands and thousands of string objects because that's the kind of object that I'm adding to that collection. When you're done with the session, you can click on this Stop button, and that will stop the profiling session, but it won't stop the app itself. To do that, I'll click on Release Memory. Now I go back to 0 items, and then if I want to stop the application completely, I can click on this Stop button, and the app is unloaded on the device. All of these profiler tools for memory, CPU, network, and energy are all incredibly valuable for seeing what's going on inside your app when you run it on your Android device. Every Android app needs a launcher icon, a graphic that appears on the launcher screen that the user taps to start up the app. For my Memory Eater application that I created to demonstrate the memory profiler, I have a launcher icon that has an image of a hamburger and a shake. And when I click on the app, that graphic also shows up here in the app itself. Here's how I created it. I went to the App module, and then I right-clicked and chose New, Image Asset. In the Image Asset wizard, you can choose to create launcher icons, action bar tab icons, and a number of other kinds of icons. It says Image Asset, but it's really designed just for icons. Each icon has a foreground layer and a background layer, and there are also certain options available that let you create legacy versions of these icons for older versions of Android. In the foreground layer, I selected clip art, and then I clicked here, and then I typed food to search for something that I could eat, and I found fast food. I selected it, and then I resized that image. You can do this with this slider, and you want to make sure everything fits inside this circular guideline. You're actually creating a number of different versions of the icon, and these icons will be selected dynamically by whichever version of Android is running on the hosting device. You can also trim the image, and when you like the sizing, then you're ready to move on to the background layer. The background layer can either be your own image, or you can choose a static color. I'm going to scroll over and choose this color, and now I'm ready to generate the icon. I'll click Next, and I'll see a list of all the files that are going to be created. Notice that you're getting a whole bunch of PNG files, and they're going to be stored in a resource directory that starts with mipmap, and each version is designed for a device with a particular pixel density. Going back a step, under Options, you can also indicate whether you want to create a Play Store icon, and that would be an icon that's 512 pixels square. And that's this file right here. When you click Finish, you'll regenerate your icon. If you have a whole bunch of new files, you'll want to go and select all of them and add them to your GitHub repository, if you have one. Now I'm going to relaunch my application on the device. And I'll go back to the home screen, and I'll see that the background color has changed because I regenerated that icon. And if I click and slide up to see all of my apps, I see the icon represented here as well. This ability to generate a launcher icon makes it really easy to create this really critical graphic that every user sees when they install it on their Android device. I previously showed how to generate a launcher icon, a graphic that the user sees on their launcher screen and in the Google Play Store. You can also use Android Studio to generate other kinds of graphics. Many Android apps use vector graphics as icons that appear at the toolbar at the top of the screen. It's best to use vector graphics for this rather than bitmaps because they resize automatically, and you don't have to have different versions for different pixel densities. To create these, select your app module, and then you can either right-click and choose New, or go to the menu and choose File New. From there, choose Vector Asset. You can either use clip art that's built into Android Studio, or you can use your own files in SVG or PSD format. I'm going to use clip art. Let's say that I want my application to be able to delete something. That operation is traditionally represented by a trash can icon. I'll click the clip art button, and then in this text box I'll type delete, and I see a whole bunch of different icons available. A simple delete icon, delete forever, and so on. I'll choose the standard delete icon and click OK. A name will be assigned. You can shorten this if you like. For example, I'll say I don't need the 24 because I don't care about the size, and I don't care about the word baseline. All I want is delete. IC stands for icon, and this is a resource identifier, so it has to be lowercase, no spaces. I can also set the color now, but I'll be able to change that color later in the code. I'll click Next, and then I'll click Finish. Now I'll go to my Resources directory to Drawable, and here's my new file. If I'm prompted to add the file to Git, I'll click on Add because it becomes a part of my application. And here's the result. Notice that the tint is set to an attribute. It's important to use an attribute for this rather than a hard-coded color, because this attribute will have different meanings depending on whether the device is in standard mode or night or dark mode. Now I can use that icon anywhere I like. So for example, let's say I wanted to create a menu. I'll click on the resource directory and right-click, and I'll choose New, Android Resource File. I'll set the resource type to Menu, and I'll call this Main Menu. It's going to go into a new menu directory, and I'll click OK, and add this file to my GitHub repository. Next, I'll add a new menu item, and then I'll click here for the icon. I'll click this Browse button and choose IC Delete. And then, under Show as Action, I'll choose If Room, and that means show this as an icon, and you can see right here that if I display this menu, I'll get this trash can icon. Those are the basics. Now again, even though this is a graphical file, it's declared completely in text in XML, and you can modify it in code. And again, remember that the tint should be an attribute, not a hard-coded color, so that this icon can adjust as the device changes its display mode. Android Studio has a tool called the Motion Editor that makes it easy to set up simple animations. To demonstrate this, I'll create a new project, and I'll base it on the empty activity template. And I'll name the new project Motion Editor. In this project, I want to animate a graphic, and so my first step is to create a graphic that I can use. In my project window, I'll right-click on the app module and choose New Vector Asset. I'll click the Clip Art button, and I'll type basketball. And there's a sports basketball icon. I'll choose that and click through to create the graphic. And that creates the file in the resource directory under Drawable. Now I want to display the graphic in my activity. My project was created with an initial layout called activity_main, and I'm going to use the Command or Control key and then click on that to jump to the file. I'll use the palette, and I'm going to drag and drop an image view object into place, and then I'll choose my new graphic, the basketball, to display. Next, I'll set the layout width and height to 100 dp each. And I'll do that in the Attributes window over here. And now I can see the basketball image. And next I'm going to constrain that object so it starts off at the top and at the left. And I'll set the value of the margin in both cases to 0. So that's the starting state of my animation. The next step is to change the constraint layout to something called a motion layout. I'll go to my component tree right here, I'll right-click and choose Convert to Motion Layout. And when prompted, I'll click Convert. And let's take a look at the code that's been generated so far. My root element is a motion layout instead of constraint layout. Then I have my text view and my image view. And my layout width and height are both set to 100 dp. Now, because these are both identical, I want to save this value as a resource. I'll place the cursor in that value, then I'll use an intention action and extract the dimension resource, and I'll call it basketball size. Then I'll copy this string, and I'll replace it here, and now I'm using the same size for both the width and the height. I'll look at it in Design View, and I see that the image is still in the same place. When I added the motion layout, that resulted in creating something called a start constraint set, and that's the initial position of the object. Now I'm going to say what the end position is. I'll click on the end state, then I'll click on the basketball over here. I'll click on that constraint set, then down here I'll select the image view again, and I'll remove the constraints on the top and left. Now, when I go and look at code, I won't see anything here that's indicating where these states are stored. Instead, there's a new file that's been generated called the activity main scene, and it's in the XML subdirectory of resources. I'll command and click to get to that. And here are my constraint sets. I see that there's a duration of 1000 milliseconds or 1 second, and I see my constraints are listed down here. Now, when I did the constraint, for some reason, it added end to start of. And I'm going to say that's end to end of instead. And I'll change that to parent. Then I'll go back to the XML layout file, look at it in Design View, and now in my end state, the basketball's in the lower right corner, and in the beginning state or start state, it's in the top left. Next, I want to look at the transition and preview it. To do that, I'll click on this button that cycles between the different layouts until I see the transitions. I'll click on the start to end transition, and now I can scrub through the transition this way, or I can play it in a loop. Next, I need to trigger the transition. And to do that, I'll add an event handler. I'll click this button to create a click handler and choose click handler here. And I'll say that I want to trigger this transition when the user clicks on the image view component. And I'll click on add. And now I'm ready to run the application. When the app first appears, the basketball shows up in the top left corner. When I click it the first time, it goes to the lower right. When I click it again, it goes back in the other direction. So that's a simple introduction to the Motion Editor window. It gives you the ability to set up simple animations. And there's more to learn about the motion layout component. For example, you can add debugging functionality. I'm going to go to my motion layout and I'm going to add a show paths attribute and set it to a value of true. And then I'll add motion debug and set it to show all. And then I'll run the application again. Now, down at the bottom, I'm seeing debug information, and I'm seeing this dashed line showing what the path is going to be. Each time I click, I see the number of frames per second, and I also see the percentage progress of the transition. The Motion Layout Container and Android Studio's Motion Editor make it easy to get started defining these simple animations. Android Studio Arctic Fox supports a new programming paradigm for Android apps called Jetpack Compose. This is a code-based approach to building user interfaces, and you can get started easily with Jetpack Compose by creating a new application that uses an activity template for this style of coding. To demonstrate this, I'll create a brand new project, and then I'm going to create it from the empty Compose activity template. I'll give this a name of Jetpack Compose and create it. When you create an application that uses Jetpack Compose, you won't have XML layout files. Instead, your user interface is completely built with code. So in this main activity class, I have an onCreate function, and it's calling a function called setContent. That in turn is creating something called a Jetpack Compose theme, and then a surface, which is what the user sees, and then there's a call to a function here, greeting. The greeting function creates a single text object with the value of hello, and then whatever value is passed into it, and you can see here that the value Android is being passed in. Android Studio has the ability to preview these applications. When you open a Jetpack Compose class, you'll see this preview screen over here, and if you then click on Build and Refresh, after a moment, you'll see a rendering of approximately what the app might look like. So that's not very impressive. What we really want to see is what this is going to look like on an actual device. So I'm going to choose my virtual device that mimics a Pixel 3a running on API 30 or Android 11, and I'll run the application. So when the application comes to the screen, I see Hello Android. Now notice in the code, first of all, you can control the look of your application with the theme. And you can find out how the theme is set up by holding down the Command key on Mac or Control on Windows, and then clicking into the theme. And here you'll see some conditional code that basically says if we're in dark mode, use the dark color palette, otherwise use the light color palette. And then there's a declaration of something called material theme that's setting colors, typography, shapes, and content. You'll also see up here a listing of the colors that are being used in the two palettes, dark and light. So the idea is that everything is being built here in Kotlin code. There isn't this mishmash of business logic, XML files, various resource files, and so on. As much as possible is being done in pure code when you build an application using Jetpack Compose. Now, this is a very simple Hello World application, and you can do a lot more that's much more complex with this sort of application building. And so next, I'll show you some sample applications that are built with Jetpack Compose. The best way to learn about new features of the Android SDK is to find working sample applications. And as I showed previously, you can get to these sample applications through the Android Studio welcome screen. For Jetpack Compose, I'll go to the welcome screen's options menu and choose Import an Android Code Sample, and then I'll search for the word Compose. And I'll see that there are a whole bunch of different applications I can inspect. I'm going to choose the Jet News sample, and this is a news reading app, and I'll click through and download and create my project. As always with the samples you get from GitHub, you'll see an MD or Markdown file that includes a description of everything that this application does and how it's structured. Let's take a look at some of the code over here. I'll go to the project window and to the project scope. Then I'll drill down to the app module and the source, the main directory, and then the main package. There's a whole bunch of different sub-packages. And, for example, this is called the Jet News app class, and it has a bunch of Compose functionality. Notice that this application uses the navigation component. This is one of the architecture components or Jetpack libraries, and it's a good reminder that even though Jetpack Compose is a different way of composing or building your application, you can still use a lot of the common functionality that's used by all Android apps. That includes UI assistance like the navigation component, data persistent components like the room library, and so on. I'm going to run this app in my virtual device so we can see exactly what it does. When the application is completely built, it'll be installed on my device. And I can click and drag up and down to see all the different news articles. And I can click into an article to see the details. Notice that the application has features for bookmarking, sharing, and so on. And again, the goal of this application is not to implement a bunch of features, but to show you as a developer how it's done. To investigate this further, take a look at the README file and check out all the different code samples. And again, there are many other code samples for Jetpack Compose. So what do you need in order to build your apps with Jetpack Compose? You need Android Studio Arctic Fox, the product that's been the topic of this course. As of this final recording, Android Studio Arctic Fox has gone stable, and it's now ready for use in your production Android apps. Thanks for watching this course on working with Android Studio Arctic Fox. To learn more about developing Android apps, you can watch the courses in this series, Android Development Essential Training. It's a multi-part series. It'll take you from building your very first Android app through understanding the architecture of Android apps to creating a user interface, working with local and remote data, and many more aspects of the architecture of Android app development. As I mentioned early in this course, Android is a Kotlin-first platform now, and so the more you know about the Kotlin programming language, the more effective you can be. To learn about the basic programming language, watch this course, and then look for other courses in the library that look at how to use Kotlin specifically in building Android applications. These courses and many more are available to help you build your Android development skills.